Up here. I have the audio amp split apart right now and sitting on the desk, so I'm kind of locked in. Oh, he did a set last. That's what this is? Is this from 13 hours ago? Oh my god. I missed it. I went to bed early. I gotta start getting to bed at like a normal human being time. It's gonna benefit me very, very greatly. That's a Borb shirt. I still have the mug. I need to, by the way, I revealed your undercover dono by accident because it was on Chatterino and I forgot to clear Chatterino. I'm gonna mute and go get my Red Bull. I can't get away from here. Give me 1 sec. Rainy day today. I love it. Perfect day to do this kind of stuff, right? I got insulin. Apparently the insulin prescription, much unlike the ADHD medication, can be refilled very quickly. Am I a little bright on this camera? I guess I look kind of normal. It's the black shirt, I guess, this is the black and red one that I got. Yeah, but the like Concerta and stuff like that, the ADHD med that I take, you cannot get until exactly the day to the month when it expires. Whereas insulin was 6 or 7 days early, and it went through. Like I called the pharmacist like nearly in a panic, like I'm not gonna make it the 6 days until this thing is done. He's like, oh, don't worry, whatever, I got it. Don't worry about this. And I'm like, listen, I can. He's like, can you do tomorrow? Can you do tomorrow? Cause I can get this tomorrow. I'm like, are you sure you can get this tomorrow? Because yeah, I could get this tomorrow. It's like, oh, okay. Like, cause that takes a couple days. Like, right? That's another day, and I have a couple days until I'm out. In which case, if insurance says no, then I have to call Penn Medicine, which takes several days to do their thing. So this is like peak stress for diabetes, and apparently insulin can be filled a little bit early. Insurance is totally fine with it. But like all the timings, like if you plot out the timings and what could possibly happen and what might not happen, yeah. Because sometimes either CVS or the doctor's office will just ignore stuff. They just won't respond to anything. Anyway, Fatanon, thank you for the tier 3 for 32 months. That's insane, and I love you. Thank you so much. I really appreciate 32 months of tier 3. That's insane. Now, we're listening to Metronomic from last night. Apparently, you did a really good set. I was asleep because I got to bed early for once in my freaking life. I got to bed early, and then I sat in bed until late, which is great. It's just great. I'll do it again tonight, and I'll probably get to sleep on time. But, yeah, so that's that. I cooked a pot roast before starting off today. You know, once I did all the insulin stuff. Hoping my, yeah, update subs, set burner order where 0 equals username Fatanon. Shit! We did it! I didn't even notice. Oh look, Cannibal Jesus has actually decided to stop playing Satisfactory for 5 minutes and leave a comment in chat. He's like, no, I still have it open in another window. But yeah, so I I cooked a pot roast earlier, and I got grill burns and steam burns, and I did the searing out of order. I was like, I wasn't thinking, and I was kind of tired and kind of a little stressed out, and so what I've been doing lately is with the pot roast, I've been searing it on the barbecue because there's a lot of good stuff left over on the grill plates. So I sear it on the barbecue and get all that wonderful, like, all the oils from burgers the night before, right? Enhance the flavor. Get a good sear going on that, brought it back inside, and went, you know what? I have a beer here. I have Yard's, like golden ale. It's your fault I have this crippling Satisfactory addiction. Coffee Stain is streaming right now. I was watching that earlier. Yeah, you really can't. I'm a testament to the fact that you cannot screw up a pot roast. Here, hold on. I need to do the face procedure. Boop. That looks about the same. Never mind. I think it's the shirt. The camera thinks that there's way less light, and so it's doing stuff. It shouldn't be doing auto adjusting, but so I sear the pot roast on the grill, bring it inside. That's after it's salt and peppered and allowed to get to room temperature and all that stuff. Bring it inside, and then I have all the ingredients chopped for me by a roommate. So what I did is I put some of the raw ingredients in the bottom of the crock pot, and I'm like, wait a minute, like I need like a sear on this pan because I have this beer that I want to add to it. So what I did is I moved some of the vegetables back to a pan with oil. Oh no, before I did that, I seared the sides of the big piece of beef in the pan so that I could get a little bit of beef grease in the pan. I also cut a little piece of fat that I put in there as well, just to get some beef stuff going in the pan, right? What's up, Future Class D&B? Drum and the Boss. So yeah, I get all that stuff going in the pan, right? With the veggies. Actually, no. Sorry. I got all the beef. I seared the beef in the... See, I can't even remember the order properly. I seared the beef in the pan, the sides of the beef, right? Because I got grill marks on the rest of it. Put that in the crock pot, and then I poured the beer in there and made a huge bubbling mess. And I was like, oh shit, wait a minute. I'm not supposed to boil the vegetables in the beer. That's dumb. So I dumped the beer in the crock pot, and then I sift vegetables out of the hot beer and put that in the pan, and then I do all the dishes, because apparently it takes 500 dishes in order to cut a couple vegetables up and get some spices together. I don't know. I don't understand it, but I did all that, started the dishwasher. By then, the veggies had left a really nice sear on the pan. Dump the veggies over, pour the rest of the beer, which was like this much, and it wasn't enough. The beer boiled off like almost immediately. It's like, ah, shit, son of a bit. So then I had to tip the crock pot in order to get the beer that I had dumped in there previously out, and I ended up steam burning my palm as a result, because the big ceramic crock pot steered all of that hot steam up into my palm, which I can feel right now. It's not a bad burn, it just feels a little bit hot. Finally, that gave me the deglaze that I wanted, and I dumped that in, and then chicken stock, and then the bay leaf and all that stuff. Closed it, set it for 3.5 hours. Now that might sound like not enough time, but our crock pot sucks. The low setting is the high set, and the high setting is the ruin setting. So 3.5 hours in that, and then it's gonna sit until dinner time. So I think I did okay, because some of the vegetables are seared. Some of them are just gonna, boil in all the ingredients and hopefully boil down into almost nothing. There's beer in it, and the alcohol's been somewhat seared off. There is carbon in it from all the different stages of roasting stuff. I think I'm in good shape. I think it'll be all right. I didn't put garlic in. Does garlic go in a crock pot? Or garlic go in a pot roast? I don't think it does. Yeah, we didn't do potato. Potato has to be added a little later on. It's parsnip, celery, carrot, and onion. Oop, copyrighted song. We got a copyright strike. Not a strike. We just have a copyright. Garlic good? Well, I didn't put garlic in it. Watch, it'll be the best roast I ever made. Yeah, because it's got some of my flesh in it. Ow. This actually, I am starting to feel that a little bit here. Garlic gaming. No! No! Yeah, I should have chosen a mundane object. Hey, I just documented all of the steps right then and there. Hey, Mystery 836. This is what I was... Hold on, I'm gonna cough. This persistent cough I've had for like over a year. This is the noise that I'm talking about, by the way. I'll get into the nitty-gritty in a little bit, but this has nothing to do with the this has nothing to do with the audio project, save that I can't see audio on this. But check this out. So we're going to be working in the dark for a little bit today. But this is what I was talking about. Mr. 836 was actually confused about what I was talking about with the noise. He thought I was talking about the actual audio amplification, which I technically am, but in order to take a look at what's going on here, this is line level voltage right here, right? Line level being 1 volt peak to peak. And so if I turn off my desk lights, son of a bitch. This looks on, None of that comes through in the audio in the end because it's common mode noise. But my filter, oh, you think Pyro was, whoever was confused anyway, this is what I'm talking about. Common mode noise is naturally filtered out by the differential amplifier of the audio setup, but this scope will not just natively put stuff through a differential amplifier. I have to use a math function, which is technically digital, which takes a little bit of time to execute. So the output of that is a little bit more rough. Plus you have to look at this mess with the line under it. So this doesn't really help filtering it out in the scope. But yeah, this is the noise that I'm talking about. This is a good song. So I bought a couple filters that I'm going to be putting in the path of the lights, and hopefully some of them get rid of it. It means I need to move the computer away from that pylon so that I can take off the cover, and there's a bunch of stuff that's basically double-sided taped up against the metal pylon of the desk. And I'll put a, yeah, that's the thing. I got some chokes that I'm going to put on the power to the lights, which is the cable over here. Probably if I touch that, it changes. Yeah, it's changing stuff when I touch that wire. I'm going to put a choke on that, and then I'm going to put a choke on the AC input to the light to make sure that this isn't fed back through the power supply. I used to have a really nice choke filter cable on this scope. I don't think it reduces the noise because most of the noise is probably being picked up by this coil right here. Yeah, it's sensitive enough that when I move it around, you can see. I might be able to defeat some of it by pulling in another ground, a local ground. That might filter it out, but anyway, yeah. Friggin' Metronomic Live, man. Doing some pretty awesome streams. Oh, and I have an update about the cider. If you don't notice, there's a ladle sitting on top of the carboy, and a lot of it is missing. It is extremely tart. Now, I've been told in the past by certain somebody that it's actually very good. It tastes like green apple juice, right? Very tart. But I'll admit, I think what it's doing is alerting my stomach. Do you have 220 volt to the room? Just split one for the lights and crap and the other for electronics. I could probably do that. But the problem is well, actually, if I plug that into the other side, maybe it'll help. Yeah, maybe I could do that. Because I do have one side of the room is one circuit, the other side of the room is the other circuit. One phase versus the other phase. What's going on here? Hey, what do you do? What do you do? What the dog doing? Eh. All right, anyway. Yeah, so I had a bunch of that cider over the past 2 nights. Or 3 nights actually, since Halloween and stuff. It causes like stomach distress and extreme flatulence. I don't know what it is. Maybe it's my gut biome reacting to apple juice, but yeah, I knew that was coming. You guys are anything if not predictable. Yeah, it causes extreme flatulence, like extreme. Like, I don't know what it is about my body, but it's like, oh, you had some of that? Let's get rid of it. I don't know what it is. I don't know. Maybe it's something else that's causing that, but I have a feeling that it's this stuff because I had 1 glass of it and then my stomach sank and I just felt like ugh. And then a couple like maybe 10 minutes later I was basically replicating what the fart machine does. So I don't know. I might apple juice is serious stuff. Listen, I don't get a lot of heavily carbohydrated things, and that shouldn't have a lot of carbohydrate in it. That's why it's so tart. But when I get the purer of the sugars, like if I eat candy, which I did on Halloween, so I thought it might have been the candy. I started basically becoming a hovercraft. I don't understand it. I don't know what the deal is, but yeah, I'm gonna lay off of it tonight, and we'll see what happens. I wanted to try out the first batch, but I don't know. Maybe it's the yeast. Maybe it's the champagne yeast. Yeah, I'll take them down. I'll take them down myself. I'll put on a kilt. But yeah, no. I don't know what it is. It could be other food, though. I could just be eating like crap. It could be the change of seasons. It's a supercharged probiotic. You want to make sure that nothing's in your entire gut? I'll carbonate. I'm going to leave the second batch for another week or two, and then I'll force carbonate it, which will change the flavor profile a little bit. The aging and the forced carbonation will change the carbonation helps with a cloyingly sweet flavor. A Bridgewater, thank you for the 14 months. The left or the right what? Oh, you mean on the waveforms? Bothers's cider cleanse diet. I feel like a windsock. Try Bothers's cider cleanse diet. Yeah, but so anyway, this is a pun on the word list. You're on a list. Am I on the left? Listing. Oh, am I listing? I didn't read that word. Oh man. All right. Funny joke. Sorry. I missed the one key word in that sentence, but I was in the middle of talking about something else, and I just lost everything. You took everything from me. Oh, there's xylophone in this song. Sort of. Yeah, so I think what I'm gonna do is force carbonate the other batch and bottle it. I'll give it to friends, but I gotta give them a warning. Like, hey, this caused me to like fart my absolute brain out. Try it at your own risk. Because people have had it and they're like, it's really good. Not this batch, but this batch is made up of the exact same stuff. So I think it's me. I think it's me. Good baseline. What else do I got going on? Not much. Not much. Finally had that insulin stuff resolved. In the factory, my satisfactory playthrough, I actually have all 10 items coming into the smelting building. It's not entirely smelting. There's like, I'm making gunpowder in the same building. I don't know why. Probably because I don't want to run sulfur through the rest of my base. But yeah, the Coffee Stain was doing they were doing a stream earlier. They probably still are, but I got to see, they were like, we wanted to enable you to build these kinds of factories, and they show all these wonderful looking things. And then they show what users have made next to that, and it was just about the same thing, which is insane. And I'm like, I have a shoebox in the desert. How's my factory? It doesn't look as fancy as what other people are making. But yeah, I got all 10 of the ingredients into the building, and then I got all 10 of the outputs out of the building. So I'm pretty excited about that. I ran everything to the edge of a cliff and then had them all go through lifters with the new special floor holes for lifters. So they're all going down into that big umbilical building. That umbilical building is actually the largest building of the base now. But I've got everything kind of worked out. I'm still riding the fix-it cart to get back and forth, though. That's the annoying part. But every single line that I've run in there has almost full potential. And I think there are places where I can put additional belts into the belts, because I think one of the irons is a little bit slow. But I can add to it if I need to. One of the coal line is running along a beach, and it does an entire C-shaped turn into the back of the manufacturing supply building. It's a little ridiculous, but I love this system because it cleans everything up so much. This is theoretically in the future. I'm doing the refinery now, and every time I look at it, I just like sigh heavily. And there's something wrong, like with the experimental build of the game. It keeps crashing on me. When I'm just like flying around the factory, it'll just crash. When I'm flying around the refinery area specifically. Oh my god, what is this song? Yeah, there's an update today that should fix a couple of the bugs. This needs to be lower. I'm looking too far up into the air. Oh, I haven't adjusted tension on this one. Ugh! These monitors are so light that Oh god, I think I have to fast forward beyond this song. It's a little too shouty. Please go further down, you stupid monitor mount. Oh, it got copies. No, it's actually lagging now. Did I break my internet? Am I still up? Everything says I'm still up. Ooh, I almost spilled Red Bull over everything. Red Bull? All correct, it'll do some very splotchy renderings of stuff, like little dots everywhere, because it's basically taking a ray tracing method. This looks blown out. Oh, it's because there's plenty of light. Although, why isn't this coming on? I think the toggle on this thing failed. Let's do desk toggle. No, stand toggle. What? Why isn't it turning on? Oh, because I turned it off for noise purposes, right? Like if I turn off the desk, there's actually, this one's not causing all that much noise. Although it is easier to see stuff with that one off. Blech. Okay, song, what are you doing? Song, hello? Hello? Can we get a little bit of a song? Boy. All right. Analog audio. Wait, do I already have a window open with like 1,000 links? No, I just have that one. Okay, so I gotta drag them all over here. Here's the LF353. 2337. This one is some other audio amp that I have. OPA 2337. Opa! Okay, the LF. MMBT 3904. This is a 3903. That's not even the right. Oh, 3903 and 3904. All right, there we go. Anything happen over the break? That was 2 days ago, 2 days ago, 2 days ago, 23 minutes ago, 9 minutes ago. Anthe1448 followed. Finn Codius. Little Johnny Deep 3. The Torque. That one we got during stream, right? Yeah, 2 days ago. Cool. Well, hey, thank you guys. The Outer Planets Alliance. Opa. Opa! This is getting deep. I wish I could just play the Dune theme, because that's been in my head for about a month. That's not true, the movie hasn't been out for a month. But anyway, that theme has just been in my head. Pyro called it the Egypt theme, but it's not Egyptian, it's just... it's just Hans Zimmer. Hans Zimmer being Hans Zimmer. My God. He's achieved perfect he's done a perfect Hans Zimmer impression. And he's Hans Zimmer. It's good. You watch it for the cinematography, and you watch it for the, you know, the whole burrito of ingredients that it's created. Can't render fully because I'm not in premium. Yeah, that's where they limit you. That's where they limit you. I don't find renders to be all that satisfying, though. Let's be honest. I would rather just build the parts in a sort of like representative drawing. I have read all of this, but I've forgotten all of this as well. I need to reread this document. It's hard to take in all this stuff at once, though. It's hard to take all this in and retain it. And here comes that one chatter to be like, actually, I read all of it and I remember all of it, bother. All right, I get it. You're smart. You're so wonderfully smart. Thank you. Thank you for that. You need charisma. But no, anyway, this is tough. It's tough to read all this stuff about audio amplification and differentials and all that stuff. And like keep it in your head. You know, this is like a dense text. It's cool knowledge. Who's talking about wireless right now? Jesus Christ, dude. I don't give a shit if you like. We're not talking about wireless. We're talking about actually sending audio signals into microphones. You're gonna even if you do a wireless lav, you're gonna need to do this in the end. Rabble, rabble, rabble. So yeah, this is where I got the inspiration to use the Zener diode, I believe. And there was only mention of using the Zener diode on the audio circuit from Elliott Sound Project. Just making conversation. It's like totally out of left field, though. What is... All right. What just shifted over there? Oh, the ice from my coffee. Over the age of 25, keeping anything in your head is next to impossible. I'm not gonna say it's not impossible to learn stuff after the age of 25. You should always be learning, right? You should always be expanding your horizons. I've learned a lot over the past couple years. Quite a bit. But, yeah, it's tough. You're better at retaining information under the age of 25. The brain loses a certain amount of plasticity as a result of aging, but it doesn't matter. Yeah, what are you on about? I'm 27, I'm still studying. Your brain loses a little bit of plasticity, but it's not that bad. All right, I think we should get started. I'm not gonna go over this today. I just have it open. Metronomic Live, by the way. I mean, look, honestly, like a lot of my thumbnails have Metro in the background of them now. At this point, he's like an integral part of this stream. He's a good person. He's really cool. You guys should follow him and check out his stream if you get a chance. If you like to just have music on while you're working or something like that, like this is a good guy to look to. I mean, if you're into that kind of like, you know, is it prog house? I forget what genre of electronic music it is. Good stuff though. All the kids are into it. Actually, the kids aren't into it. It's mostly the adults who are still going to parties are into it. Let's very, very classily and gently fade out his music to do it justice. Ah, shit, I hit pause. All right, so what are we doing today? Well, all right. Oops, hold on. Overlays. Oh, that's not, no. Setup. Start soon. There we go. Now it's just us. So, Just Ice. What are we doing? I want to work more with analog electronics. It's raining out. It's quiet in here. I have a fan on me. We have a little bit of noise in our system. That's fine. I want to work on some of this analog stuff. And if you remember, last week was the week of Mondays. Every day was a Monday. Every day sucked, and I seemed to be making more work for myself. It was a mood ruiner. It was a bit of a letdown. I had a gaming stream on Sunday because I couldn't get it all out of my head. I couldn't let go of any of it. I did a little bit more gaming on Monday because my spirits were still down, and then I finally just sat down in front of one of the projects, at least, and I worked on it a little bit in order to kind of get myself out of the funk. It also helps that the stress of having to source insulin for myself has been lifted. I think we're on track. Tomorrow is my birthday. I need one of those little doo things that I can set off. So yeah, I'm getting out of the funk. I got enough sleep and all that stuff. I think I'm in good shape. But I took a look at that circuit yesterday, and I went over it end to end. And this is the circuit that I'm using right now to talk to you guys. I found that most of... I'm not going to stream tomorrow. I'm taking my birthday off. I've been a little stressed out, and I need it. I need to not do this. So anyway, today, god damn it. Today, what I'm going to do is work on this analog circuit a little bit. We need to start probing around with the oscilloscope. Yesterday, I took a look at the circuit, and I found a couple little errors. There was a part of a differential amplifier that I didn't plug in. There were a couple bad values in the resistors. God forbid I should get something wrong in front of you guys, because everybody else is fucking Googling stuff, or maybe they have 26 years of experience in it and they feel like I need to do everything right the first time. That's not how we work here. Let me remind you that this is a stream with me doing things the way I do it. And if it helps you, I'm very happy about that, because the way I do things is the way I do things, and there's nothing else to it, right? Nothing else to it. I work on stuff. Yeah, sometimes I break stuff and we can learn how stuff breaks. Sometimes I get things wrong and then I have to correct myself. And so sometimes, sometimes you have a week of Mondays when everything's going wrong. But having the constant criticism, even if it's just joking, gets to you. It gets to you very rapidly. So you, like, I understand that you guys don't have any tact, but it gets to me. It really gets to me. Even if it's, I understand that it's joking, but it's still there. It's like, why are they all joking that I never finish anything? Anyway, so yeah, Burn the Subs 2.5 is happening. I'll work on it more on Thursday. But today we're doing audio. Yeah. All right. So, yeah, anyway, we're gonna, what I see, part of the stress of this is that, yeah, I finish every stream I start, but you try to have like a narrative on things, right? I mean, if the better streamers do this, you'll notice even the game streamers do this. You have an idea of where your stream is going, and then you have like a resolution by the end of it, right? And so I try to do that. Well, no, it's less about, hold on, no. Slow down. It's less about, you know, I do things the way I do things, but I try to wrap it up in a bow by the end of the stream. And then sometimes at the end of the stream, stuff doesn't work out. So what we're working on today is the audio stuff, and we're going to poke around this with an oscilloscope. We're going to try to get this working, and we're going to try to incorporate it into the equalizer. Now, what I've done is pulled apart my microphone, so I actually can't get up from the desk right now. I have my microphone pack pulled apart and it's sitting on the desk, and I wanted to do that because I need to get the exact same performance out of my mic pack as I do with the perforated prototyping board. And then I need to turn the perforated prototyping board into something that has an EQ on it, because I want to replicate the software VST, the plugins that I have running on my microphone, this guy right here. I want to replicate this right here on this microphone in order so that I can plug this in to a new mixer that I bought and have it sound the way that I sound right now. So I have a compressor on this, and this is actually a fairly unique compressor because I'm actually boosting the lower the lower volume, and I am tamping down the higher volume. But you'll notice that I have a certain audio level on this thing, and that's all good. But that's sort of what I think I can replicate this inside the mixer. I think the mixer's plugins can do this. I can't do this with the mixer. It doesn't do this kind of EQ. It already assumes that you've got a microphone that's tuned, whereas I got a lavalier microphone from a friend of mine who does movie audio in New York City. I think movie and like TV show audio. So he has all of these ridiculous high quality microphones. A Tram TR. It's a Tram T something 50 lavalier microphone, and it is extremely high quality. He doesn't like them, but whatever. I'm not gonna say no. But yeah, what is it called? TR50. Okay. It's a TR50. It's expensive. It's movie quality. My friend hates them. Not hates them. He doesn't like them. But he sent me one for free because he just had it sitting around. So I ended up doing all of this stuff with the VST filters in order to make my audio sound really good. And it's become kind of my signature sound. It's actually a really good sound for my voice. All of the qualities of my voice are properly, amplified in this thing. It's not like Let's Game It Out where he boosts his bass to the nth degree. I can at least kind of like whatever. It sounds good, right? And I can't get this out of the mixer that I bought. So what I'm trying to do is I'm trying to incorporate this this equalizer in analog audio in the microphone pack itself. Because what I figure is I've got a power supply and I can actually do all of the editing to the frequencies early on. Now, where'd the circuit go? That's right, here's the circuit. So here's the circuit. Now, what's going on in this circuit? Well, hell if I know. I'm not an expert in analog audio, right? Not an expert in analog audio, but what I do know is the Elliott Sound Project page, and that's where the schematic comes from, and I've modified it. So the Elliott Sound archives, which are linked in that thing that Fadanon, in the command Fadanon, that's the Elliott Sound. You can find a lot of very like near pro analog audio stuff from that page. It takes a lot of reading. And it takes a lot of open web pages in order to oh, I'm sorry, Dewey did it. Dewey's leaving because I called him Fadanon. I'm sorry. I didn't look. I'm terrible at looking. So yeah, anyway, Dewey linked the microphone project, which gave me the name of the microphone that I keep forgetting. And it's Elliott Sound Projects, and it's got all this wonderful stuff about what you can do with basic circuitry in order to create near pro audio, right? This is a very one-to-one microphone replication that I've got going on right here, minus the little box that I put in for the equalizer. So if this is connected straight over, that's the microphone. What's happening here is we are extracting 10 volts from the 40-volt offset that exists on the microphone line. It's called phantom power. Phantom power puts a lot of power, a lot of voltage onto the microphone as an offset that is then ignored by the differential amplifier. That's what I have open over here. These are balanced audio lines. And so when you have an offset voltage on, when you have that offset voltage on your differential signal, common mode noise gets deleted. You do not hear the common mode noise because it affects both lines. That's why I can exist in an environment like this with all the noise from these lights over there not affecting my audio. So what's happening over in that left part of the circuit there, or sorry, the right part of the circuit. Okay. What's happening over here is we are extracting the power from the circuit and we are filtering the audio out of our power lines. That's what those two transistors do. They make sure that the power line stays at power without wibbling about with the excess AC voltage that we're putting on the line. We're putting millivolts onto the line, but the line is sitting at like 10 volts. It's ridiculous. But yeah, those transistors are there solely to keep that away. I have added a Zener diode instead of a resistor here because it provides more stable voltage, 9.95 or something like that. volts going into my electronics. So I have power here and here on that rail in order to run more op amps or more transistors or whatever, right? That's my thought about this. Now, what's happening in the circuit is you have what's called an electret microphone, which is a piezoelectric device. When vibration hits the piezoelectric material, it's going to induce a tiny little voltage. I guess something's going on here with powering it and filtering out AC or whatever. I don't know. Capacitors are AC blockers, so I don't know why that capacitor is there. Anyway, what's going on is DC blocker, right? Caps are DC blockers, or are they AC blockers? I forget. They put AC out of phase. These are DC blockers. Anyway, DC blocker. Okay, yeah. So this is blocking the DC. So this is blocking the supply voltage from the line and leaving us with a very small, about 50 millivolt wibbly line there. It's compared to whatever the hell's going on here with our virtual ground, and then amplified either by unity gain or by 33K and 33K. I don't know what the ratio comes out to be from that, but the feedback amplifier, this is like a classic design. You'll study this in EE like 201 or something like that. They're annoying. They're basically wizard math. This is wizard poison inside of this thing. It's just wizard math. Something weird is going on, and it probably involves a little bit of the dark arts. I think Satan's aware of differential amplifiers. But anyway, this thing will amplify the signal by a little bit, and then it'll send it out here as basically a, what do you call it? I think it's 1 volt. It should be 1 volt peak to peak for maximum volume, right? 1 volt peak to peak should probably be coming out of there. But we've got a DC blocker and then a little bit of a 100 ohm resistor in order to reduce the gain, and that goes directly out to our you can't see that. It goes directly out to the for me the Focusrite 2i2, but it goes directly out to your microphone thing, which is then going to pick out the differential signal. But it's not really a differential signal yet, is it? Now technically, if you leave the other line floating or at ground or something like that, you can put your AC on one of the signals, and then technically there is a differential between it. You don't get as much gain on the outset, but it's not really necessary to put a line on both of them. Maybe I do, just because. And so what's happening here, what Elliot's doing here, is he's got another amplifier here. And I think it's running at unity gain, I think. I'm not sure. He's got 33 on both of these lines. I don't know. But anyway, he's running one, but he's running it into the negative input of the differential amplifier instead of into the positive input like he does over here, right? And so this will invert the signal. So now the difference between these two signals here is our AC audio. It's our differential audio signal. And that's what gives us our audio out. So it's taken me a little while to get up to this point with this circuit. I know it seems extremely simple from this perspective, but we've still got like this incredibly weird virtual ground thing going on over here, which I don't really know how to resolve. Here, let me actually make the window a little bit smaller. Twisted Sister, thank you for gifting a sub to Ashridel. Appreciate it. Okay, so yeah, 472 gifts. Twisted Sister is not going in light to this shit, and I appreciate it. Twisted Sister is a friend of mine from way back in the day, back when I was in DC. Yeah, he's a cool guy. He's an overall just cool guy, and he's been getting. He's got a whole like workshop and everything too, and it's pretty friggin' awesome. All right, so that's analog audio, right? That's what you're listening to right now. You're listening to this with a short right here, right? Your emotes are. Thank you. I need to change up the emotes. Everything's getting a little crusty, so I need to change up the emotes. I'm going to change up my audio setup a little bit here, and I probably need to redo everything in OBS to make it look good. But I'll work on some more. I got to get some good ones. I got some ideas. I don't know. I'm calling it virtual ground. I've labeled it here, but there should be a question mark after it. There should be a question mark after virtual ground right there, because I'm not sure what the hell that part of the circuit is doing. I think maybe if I look up a little bit more about, like on this page, I might actually, this is balanced interfaces.pdf, right? Design of high performance balanced audio interfaces, right? So I need to read up on this a little bit more, because I think now, given my experience with this stuff, I might have a bit more of an understanding of how this document is like doing what it's doing, and what exactly is going on here. Because I feel like a lot of this stuff, I just learned about the mirror tool in Fusion 360. I feel stupid now. The mirror tool has its places, but it doesn't exist on the timeline, at least in sketches. There's probably, I don't know, maybe the mirror tool works in the three-dimensional editing, but in the actual sketching of Fusion 360, the mirror tool doesn't exist on the timeline, so I can't go back and edit stuff in the mirrors, so it's kind of a little dangerous. Multiple grounds, one that's DC common, another that's AC. Yeah, I don't know. So I gotta learn a little bit about that, because that's the part that still mystifies me in the circuit. And I feel like, you know, these kinds of shenanigans that are going on here might help to explain what's going on in the Elliott Sound project. I think that's why I got this PDF, because I feel like a lot of these structures are what's actually being replicated here, but Elliott seems to like to make things a little harder to understand. See, there's the two 100Ks, and then somehow we have a 33 and a 100U sitting here. I don't know what all of them is doing, right? 95% of that text mystifies me. You're already ahead of me. Man, I listen. It's tough. It's tough out there. It's a dog-eat-dog world. All right. So that's the circuit, right? We've got our 10-volt Zener diode that's making sure that everything has enough power. We've got only a couple hundred milliamps to play with on the sound power. We know that we have 10 volts up here, and then we have quote-unquote ground down here. Yeah, dog-eat-dog world is the bone apple tea way of saying it. So yeah, R8, getting the ground, voltage divider, maybe off of the millivolt signal, going through a 33K and being compared to itself, but that's a unity gain, so the output comes into the input and amplifies it. And then we have a capacitor, a capacitor, and a 33K going to power? The loops, there are so many loops. Hey, Nameless 770 Prime with 9 months. Love the audio streams. Excited to see the scope of this in this project. What about the scope of this project? C4 is a low pass on the virtual ground, basically supply decoupling. Okay, so we're decoupling virtual ground. And then what are we're establishing it as being, I mean, that's gonna put AC onto the virtual ground. And then this is gonna put DC onto the I don't know what the fuck's going on. You could try to explain it to me, but unless you're using like play school analogies, I'm not really gonna get it. I'm gonna need to read up on it quite a bit. I know some of you guys, Pseudo Maymay, is good to see you streaming. Thanks, man. I don't know, it's what I streamed on Sunday. I don't know where all y'all are coming from these days. I don't know if you guys know what I'm all about. There's something with op-amps needing negative feedback to allow adjustment of linear gain. Ugh, that sounds complicated. Yeah, I'll have to look it up. EV Blog, of course, EV Blog has already done it, and they've got a T-shirt on it. I'm sure. Hey, what did Brian Locke do about this circuit? Did he already put an EQ in it? Did he do that 3 months ago and I didn't know about it? Even though I had the idea on my own. I like streams. That's all. Hey, man, I'm glad you do. I'm glad you do. Yeah. So we're gonna try to figure this out. This is what I want. This is what is ideal. I want to add an EQ right here. And I happen to know that this is unperturbed audio from the Electret microphone. Now, I've also looked up a little bit about this side of the circuit too, about where I can look for and inject an actual audio signal from an Electret. R5, R6 is setting the level of the virtual ground. That would be this and this acting as a voltage divider to offset virtual ground. So voltage, I'm just going to pull up a calculator because I don't want to do math on stream, but it's it's R1 over R1 plus R2 or something like that. Dewey subbing 45 months. Been a while since I've done one of these. Hell yeah, man. Thank you so much. Yeah, math is actually notoriously tough to do on stream. So we're going to do a voltage divider calculator. It's incredibly hard to do on stream. Even the most basic stuff. And then chat is just like a force of vengeance. They're absolutely intolerable for mistakes that you might make that are like little mistakes. Because everybody apparently wants to be, you know, the PP holding a cup of coffee meme going, yes, I'm better than you. It really gets on my nerves. But the source voltage in our case is 10 volts. R1 is 33 kilo ohms, so 33, and we could actually do kilo ohms on the... You should get in the habit of doing everything in ohms and just type it out. And then R2 is 100 kilo ohms. So our output voltage is 7.5 volts is apparently our virtual ground. That really doesn't make much sense. I mean, it doesn't make sense to me. I don't know. Maybe it makes sense to you guys. Bits? Giving me bits? I think you missed seeing my earlier bits, so here's some more. Where are the other bits? Oh, 11,000 bits. Damn, dude. Thank you. And then thank you for the 200 bitums. I appreciate that. My stuff was scrolled weird. Yeah, I'm gonna miss stuff. Yeah, 11 billion bits. Thank you for the 2,154.7 bits. I appreciate that. All right. Boop boop. Oops. I gotta Control Z my way out of the circles that I keep drawing on this thing. So 7.5 volts here. But then that would be plus whatever millivolts are happening here. This is about 50 millivolts. 50-ish millivolts. So I don't know what the deal is. I don't know why that's the virtual ground. All right, we're gonna muddle our way through this, all right? So here's the deal. What I did is I sat down on Monday afternoon. I sat down and I had a little personal time with this circuit because we built this entire circuit. We built this entire circuit on the perforated prototyping board just to show you guys a little bit of how this stuff goes down, right? So we built this circuit here. And then over here, we actually built one of the equalizer circuits that Elliott Sound Projects has. So over here, we have a replica of this amplifier. Now, when we started building this thing, there were a couple primary differences. Hey, thanks for the level 1 hype train, everybody. I really appreciate that, man. You guys are great. So yeah, this right here. By the way, tomorrow is my birthday. I don't want you guys to do anything. But yeah. This is a direct replica of the circuit that I am talking to you through right now. Now, if Julian is going to be here sooner rather than later, we're waiting on one part, I may have to build another one of these. But that means that both of these circuits go through the 2i2, and they both get the exact same filter because of the way the 2i2 works, apparently. I haven't installed the Focusrite software, so I don't know if I can separate the channels out from one another. I probably should work on that, because I'll have a pretty powerful audio setup when I get that new mixer running. Anyway, yeah, this is the input that goes to the Focusrite 2i2. This is the exact circuit that we just talked about, but here, hold on. Oh yeah, so these are Switchcraft mini XLR jacks, and I don't know if you're just saying that as a joke. But these mini XLRs, you can get a 3D model of those on the Switchcraft website. You should probably use BugMeNot in order to get the login. But yeah, you can get those off of the Switchcraft website. Yeah, website's the right word. Why did it lose all meaning? Because I said it 3 times just then. I had to color the material of all the surfaces of the switch or of the jack in order to get it right for the 3D model of basically this up here. But yeah, pretty cool that you can get such a detailed model off of the website. Top side of R7 is all high Z connections. R7, high Z up here. Any contribution is going to be damped by the decoupling capacitor. But this is blocking DC, and then you've got AC here of about 50 millivolts. So why even have this if it's not going to be doing anything? I mean, this is going to be pulling it down to virtual ground. It shouldn't be. This should be AC. So what is the purpose of R7? What is R7 doing if nothing at all? It has to have a purpose, unless you're using it as like a voltage divider through the capacitor. No, that doesn't make any sense. C5, by the way, is specifically decoupling this, the dual op amp. It's written over here. In order to write this properly in a way that I would understand, it's better to put it here. Because what that does is that tells an engineer that you are specifically decoupling the power that's running into U1A. This is what I'm talking about with schematics being like hieroglyphics that are telling a specific story. What's up, Cheetah, or Cheetah 4? Okay. I already said that you guys aren't going to be able to teach this to me unless you're trying to give me play school analogies on everything. So I'm done talking about the virtual ground. I don't understand how it works. Yeah. Yeah. All right, anyway. That fucking thing is in my head. Is this about satisfactory? Not even a little bit. Okay, so this circuit right here, is an exact replica now of this circuit right here. So I should be able to unplug this. And now you guys should be able to hear me exactly the same. Only now, you're running through my perforated prototyping board. That's what you're listening to right now. Nothing changed. Exactly. This took me a little while. I had to go through the individual portions of this circuit in order to pull out all of the individual little mistakes that I made and make slight adjustments to it. And in fact, we're using a different op amp. Hold on, let me find the other op amp. What was the one we were using before? It was like the 454, the 215, 4556, right? 4556. This is the op amp we had before, right? This is the op amp we had before. It doesn't quite get the same gain. It might sound a little bit different than before. I don't know what you guys are hearing versus what we had before. Does this sound about the same? Can you guys notice any kind of a difference between the two different amps versus my voice? It sounds richer. Yeah, these are really important, Sausage Toes. Man, Sausage Toes like doesn't pay attention to dick around here. These are an important part of like science and technology kind of stuff, where like if you have only surface mount parts that do your job, the different jobs that you want to do, you can make them into through hole parts, and you can add other stuff to the circuit too. There are better ones. So yeah, listening through the highest quality. I can't believe people have me on their TVs. I appreciate that. People have me on TVs and like cell phones and stuff. And like, I wonder, like, can you read chat in this little window on your cell phone? Then again, the only reason this exists is because I am basically deluding myself into thinking that someday I'm going to be posting these up on YouTube. And I should probably just start with the first one that I ever put chat up on and just start throwing that up onto my normal YouTube page. Now, this may sound a little quieter. I'm actually like yelling at you guys right now. I'm talking very, very loudly. Yeah, I assume you guys can see it on PC, but it's a little redundant on PC because then you have chat anyway. See where the gain is? It's like jumping up and down a little bit. I mean, if I sound richer, I'll consider using this, but it looks like when I speak softly, it's not getting as much gain as the other amplifier. And so I think I'm going to be using the other amplifier in this circuit. So let's switch back to the other one. But you can see the kind of stuff that you could do with this sort of development stuff when you have a perforated prototyping board. Bap! When you have a breadboard. I don't know, man. I've just started doing this, you know. Give me one sec. Let me switch back to the other. Where did I put the other op amp? I think it's this one. I'll tell you guys, I'm not an expert in audio engineering. I am just a hobbyist. I'm an all-around kind of engineer. We sort of work in a little bit of everything around here. I would say the parts that I'm an expert in are a little bit more on the side of the automation type engineering stuff, which is why I have such an absolute. I scared your cat. I'm sorry. Listen. I would love to do all of the stuff that each individual member of chat wanted to do, but listen. I'm more of a generically skilled person, and so I am muddling my way through these kinds of projects, trying to make the best of it. I can't just, like, you know, I'm not always just working on what you guys want. So for now, what I'm doing is I'm working on a specific facet of my own studio setup, which is my own microphone. I have an oscilloscope line, because I said we were oscoping around. I have an oscilloscope line, new oscope just dropped. I have an oscope line that I've dropped on that little cut where I put the EQ, right? A little cut where I put the EQ. I've asked you to stop introducing yourself like this. And then I've got another line right here that goes directly to one of the outputs, and this is the output that's amplified. So you can see over here, now mind you, there's a lot of noise because of the lighting of my desk. Believe it or not. I'm also talking very loudly so that it shows up on the scope. But if I turn off my desk lights, all of a sudden, there's a lot more clarity to what's going on here. Now, there's a significant amount of noise on here. If I turn off this other lamp, even more of it goes away. It's just not fair. The switching noise from all of the LEDs are what's affecting noise in the millivolt scale. We've got 100 millivolt on this line, 200 on this line. Now, if I take the brightness down a little bit, I guess it doesn't allow me to take it too far down. I'm just trying to make it not, like, terrible. We do have to work in the dark a little bit today. So we take the horizontal line out there, and it's looking a little bit more like oscilloscope music. So, yeah, I have the shielding of the circuit, but I mean, you're not hearing it in the audio, I certainly hope. I certainly hope you're not hearing it in the audio. I don't think that'll do anything, to be honest. I don't think that'll do anything, because this doesn't sound differently when I close it up versus when I have it open. I think the effect is minimal at best. I think most of the noise coming in is not in the audio circuit. It's actually in these coils for my probes. Because if I touch the probe coil, like, and I have the noise present, you can see the noise change. Well, you would be able to see the noise change, but yeah, I am actually not speaking through a hurdy-gurdy. You should probably not be hearing bagpipes in the background. So what am I doing? Channel 1, I want to take that down to 100 millivolt. And we'll move channel 1 down a little bit. So yeah, this is going through the amplifier that's inverting it, and this isn't. So if I hit a tone, you can see how they are actually opposites of one another. Yeah, it's a little bouncy, but you can see it. Looks like a lot of noise is coming out of that amplifier until I actually start talking. No, it looks like it sorted itself out. That's good. But yeah, this is the output from the inverting amplifier. This is the output from the part of the circuit that normally outputs. So I have a frequency generator here, and I've been able to replicate this volume. But the problem is, if I do that for you guys, then you have to listen to a 2 kilohertz tone that's going to friggin' destroy you. It's going to absolutely obliterate you guys. I don't want to do that. So there's a chance that I could cut off the vocal part. Like I would have to possibly remove the capacitors, the resistors, and then you guys wouldn't hear the output, and I'd still get the phantom power directly from the Focusrite. And I can do that. I can hook up the second audio cable that I have. That'll get phantom power, and then I remove the 2 capacitors or move the 2 resistors from this part of the circuit that's injecting the AC audio. You can probably hear noises when I touch this stuff. But then I can cut off audio here and still get the phantom power into everything without giving it a whole lot of terrible audio for you guys. Now, I was looking for, I don't have a white noise generator. I only have this thing that I built, the circuit that I actually built a little while ago, which is the DDS function generator. This thing will only output certain functions, like sawtooth and square wave and stuff like that. You play a sick nasty guitar riff. Anyway, I could the brown noise generator. Yeah. Poop jokes. So I do have that function generator that was sent in, but I think it's dead. I don't think that function generator works. I think it has a white noise feature on it, though. So I could potentially do that. Bonesaw. I wouldn't want to be me neither. Wait, no, that's the wrong movie. That's the different... No, wait, that's the same Spider-Man. Yeah, so I got to decide how I want to do this. So these are the frequencies that are going out to the Focusrite that are... Son of a bitch, stop beeping at me. What's the... I gotta give a little bit more insulin. Yeah, look at that fucking glucose level. Jesus Christ. All right, bolus. Let's give another like 50 carbs because that'll do the max bolus. All right, there we go. My son thinks McGuire's Spider-Man 3 is the best Spider-Man movie. It's because it's been memed. It's very memed. Very memed. It's gonna get worse too with the next movie that's coming out. Petite Ricky, 2 months. Remember when I ran it 2 months ago? Now's our anniversary. How long until you put a ring on it? You're gonna have to fight a little bit more about that. He doesn't do memes. He's totally serious. Well, there's no accounting for taste, but that's his own prerogative. The Raimi Spider-Man movies they're good. They're not like they're Raimi movies, you know. So there's a certain charm to them. Has he seen Evil Dead too? See, I don't know why this is jumping around so much like that. Stay happy, much love. Yeah, you weirdo. Thank you. I really appreciate the 2 months, man. Okay, so yeah, I don't know what's going on with the audio level here while it's jumping around so much. Because like I'll stop talking. See that? And it like settles around a little bit. And then sometimes I'll talk and it'll be perfectly stable. Now that could also be the scope doing a little bit of that. And this is a digital scope, so it's not going to have exactly the best responses. There's a significant amount of lag. I don't know what you just typed means. Oh. So what we're looking at is my one audio channel, but we're looking at it pre and post amplification. The probes are here and are we pre or post? Yeah, here and here. That's where the probes are. So if I wanted to get more of an idea of the differential, I could take it here, and then that would get rid of the DC element that you guys are seeing in there. But I'm more interested in this part right here where we add the new EQ to everything else. So we can try a little bit of that. I could either create a waveform that I will inject into the other part of the circuit using the function generator. I could inject it into this part of the circuit, and we can check over this part of the circuit in order to make sure that that waveform gets from one end to the other. It'd be better if I had like a sweep, or maybe just a sweep. If we can get a sweep of a couple millivolts, namely 0.1 millivolt, and the reason that I know that is that I did all this yesterday. I didn't do the I'm trying not to, like, you know, there's a bit of like how the sausage is made where you see streamers like pretending they're seeing stuff for the first time where they haven't. Like, clearly they've vetted out part of the game. But basically, what I did yesterday was check over this part of the circuit, and I characterized some of the waveforms that we're seeing going in and out of this thing. So I know that this is about 50 millivolt peak to peak when I'm in a normal talking voice, but when I'm like getting up there on the actual thing, I can get something like 100 millivolts peak to peak. That's not the max of what this mic can do. This mic can do a lot louder. I was screaming into the little Electret microphone yesterday and crying. But yeah, so this can do a lot more volume. It's just the system doesn't like it, and it'll start peaking. So we can give about 100 millivolts with whatever offset we feel like into this, and it should, I mean, it should be at no offset, but I have these on AC coupling right now. If I put these to DC coupling, I believe they do have they have like a 6-volt offset. So if I put this on DC, it disappears, and then when I try to get it back, I run into the maximum allowable voltage offset that this scope can do, which is 2 volts. So I can't see it anymore. So I'm unable to see the waveform. But if I up channel 1 to like 3 volts, 1 volt, 2 volt, there we go. 2 volt offset, or 2 volt per div rather. Let's take that offset back up. Parameter limited. Bring it back up to normal. Oh wait, bring this back up to normal. Hello? There we go. Yeah, if I take it to there, now you can see that there's a 246 volt offset with a little wibbly line on it. And I guess that might explain the 7 volt. Notice how it settles around there too. It, like, the DC's just kind of like moving it around. It's really weird. Yeah, it seems like there's a 7 volt offset on the audio. I say 6 volts. What does this actually say? 5 milliseconds, 5 hertz, period, frequency, 5 milliseconds. Where's the actual? I don't really see it. So if I put it on the line here, 2, 4, 6. Yeah, it's maybe a little over 7.5. That's probably the 7.5 volts that we're talking about, huh? Interesting. Interesting that we'd find that there. What with the virtual ground being what it is. I suppose that's there because that would be that offset would be able to give you the dynamic up and down waves from 7 to 10 and from 7 to, I guess, 4 or something like that. So that'll give you your maximum, which is way distorting for this circuit, but it's available. If you have like a bomb go off nearby, maybe you'll be able to actually capture some of the bass frequencies that are coming out of it. Unlike any other thing which has just like rampant distortion when you hear something like that. So yeah, that gives you an insight into a little bit of what this circuit is doing. And I think IMO, that we can take this line right here, sever it, and then put it back in. I don't know if we need that 33K on the outset. I don't think we do. No, we don't, because we're taking the feed. Yeah, we're taking the other line from there. Yeah. So that's our output from the EQ is going to go directly into everything else, which begs the question whether or not I need like a unity gain amplifier on the end of it in order to make sure that it has enough oomph to get down an audio cable. But we have the inverting amplifier over there, and then we have the regular output line right there. And so that's where I think we should be taking our audio from. And that's going to be a 7.5 volt offset. And then it'll be like 100 millivolt peak to peak audio signal. Now, we tried to plug that in last time and nothing happened because we tried to plug it into this, which is a transistor-based graphic equalizer circuit. Now, by graphic equalizer, what I mean is that the equalizer takes all of the individual bands of audio. Okay, each stage of the graphic equalizer looks at the entire audio signal, and it has sort of like a bell curve of what it actually is able to hear, because your audio, your AC audio, is coming in and it's being filtered by this capacitor thingy right here. It's being filtered by the two capacitors, and then you inject it back into your audio line through a potentiometer and a resistor. So what's happening here is we are taking each individual audio signal, filtering it through a couple capacitors. We are then amplifying it or whatever. We're bringing it back out from whatever our source voltage is, and then we'll increase or decrease the gain on it in order to amplify or reduce it. And so what that allows us to do is that allows us to select like high, mid, and gain and low, and we can add or reduce gain to it. So we have different capacitor values for each of these. Now all the little slashes through the components there are just things that I've installed into the circuit. That was me trying to keep track of what the circuit looked like as I was working through it, and I'll probably have to do that again. But 0.1 UF has a particular frequency, 226 hertz. 0.022 UF has a and by the way, these aren't the only frequencies. This is the center frequency. So this is where it has the peak of allowance of frequency through it. Everything exists in kind of a logarithmic view, right? So here we have the different frequencies that we're working on. We got 3 of these circuits sitting on this board right now, and I'm still deciding whether or not I want to go with this one or if I want to go through the panametric EQ. I keep saying the wrong word. The parametric EQ puts your audio signal through a whisper down the lane type situation where each amplifier then enhances or tamps the frequencies that it's allowed to work on. But the whole audio signal goes through multiple different amplifier circuits in order to get to the end. Whereas with this one, everybody gets the same thing at the same time, and then it gets recombined into your audio signal. So your audio signals, your frequency range is a little rough by the end, but it's still passable. All right. Notice how when I try to like teach people about relays, chat's silent, or chat is belligerent and obnoxious. And when I actually get into stuff that I'm like vaguely familiar with, instead of the basics, like they're silent. I have silenced them. All right, so hot diggity dog. All right, so the BC549, we have 3904, right? BC549. Instead, we have a 3904. But where Elliot has previously called upon, the power of the BC549, I've also replaced with the 3904 to perfectly fine effect. As in, the audio that you're listening to right now is being filtered by the BC549s that I've replaced with 3904s. That's the actual component that I used, and I had to check over that. I had to go and look at the circuit again. Don't call us obnoxious. Fine, your name is Shirley. I get it. So yeah, I think all my ducks are in a row. We've got our test set up. We've got audio running through it. You guys can barely differentiate between this and the previous circuit. This is the DC offset. You guys can barely differentiate between the two circuits. So I think we're ready to jump into the EQ, which means that I need to check this thing over. So I need to turn the desk lights back on. Tell me if you guys can hear anything when I do. By the way, what's fun about me turning on and off the lights is actually, in order to turn on and off the lights, what I'm doing is I'm hitting a button on the Stream Deck, right? I'm hitting a button that turns on the desk lights on the Stream Deck. That then goes into my computer. My computer then makes an HTTP request that gets picked up by Node-RED on a Raspberry Pi that's sitting all the way over there, that then puts another request on the network, which wirelessly transmits to a device that's behind that pillar over there. Or sorry, it's in the pillar. The files are in the pillar. It's in the pillar over there, and then it goes to the lights and turns them on, and it allows AC to go to the lights. It's a big like Rube Goldberg machine. All right, so tell me if you guys can hear this difference between my voice now and between my voice now. I don't really think there is much of a difference, but there is absolutely a lot of noise sitting around the shop. There's not a lot of noise on the actual amplifier circuit, but there's a lot of noise on the output. Do I sound well? It could have been okay. So I'm doing this and I'm talking, and then I do this and I'm talking, and then I do this and I'm talking still. It's taking a minute for it to turn on. You can hear it. 1, 2, 3, 4. Bike, bike, bicycle. Pop, pop, popsicle. Test, test. 1, 2, 3. Bike, bike, bicycle. Pop, pop, popsicle. Test, test. 1, 2, 3. So I'm actually working on doing stuff that is going to get rid of that noise. Well, or at least hopefully reduce the noise to the point where it doesn't have this much of an effect. But we need to get to the point where we can actually test this. So I need to check over this circuit. Sounds about the same. I think these are over the audible level of the signal. Okay, so can we see it in the audio tools? Hold on. Let's go back over here and let's look in. So this is what you're seeing. The waves coming in the background here are, I believe, pre-filtering frequencies that this microphone is giving to the computer. Now, the computer is, of course, digitally chopping this up, and so it probably has an emphasis on certain frequencies, depending on what the Focusrite is doing inside of it, and we have no idea what that circuit looks like. There's probably all kinds of wonderful decoupling and protection and stuff like that inside of the circuit that we don't know about. But this is what at least is reported to us by the VST, which is a piece of software which is breaking it down and giving us a visualization. And so there's delays in there, and man, there's so many layers of just like things that are getting edited upon by things in audio setups. So what we're looking at is ostensibly the frequencies that are coming out of the microphone, right? And so if I turn off the lights now, is there a difference between my voice and the frequencies that you see here? See, I don't see any peaks or valley differences. So I'm going to be quiet now and do it. Yeah, it's outside of the audible frequencies, which is good, but it's bad for my scope because I can't see anything happening on the scope because there's all this noise all over it. How obnoxious. There's a very slight difference when you're going back and forth, but you wouldn't notice it otherwise. I want to eliminate it. I've got some ferrite cores that I'm going to clip around the lights, and then I've got a what is it called? It's like a line filter, like an audio line, or sorry, an AC filter that's going in. It's going to go in the cable path because it's the switcher for the 24-volt LEDs. It's a cheap thing from China. And it's just cutting, it's just PWM cutting everything. And that's what's happening with this. Can your scope do an FFT? It actually, yeah, we could do that. Let's do that. That's one of the good features of the scope. And that's why I want to be able to inject white noise into this circuit so I can actually do the full tune. Which is actually Pyro's idea, and it's a good idea. I could do an FFT into this thing. I could do white noise into this thing, and then I can FFT it. So yeah, here are the frequencies coming out. It does not look like my voice. Can I alter this? Can I zoom in on a part of it? Doesn't look like it's going to let me. I'll have to figure out how to do that at some point. But there's not too much going on here in terms of the frequencies until I turn off the lights. And then nothing happens. You see that? Beautiful. What are we FFTing? Channel 1. What's the channel 2? Channel 2. Where's hello? 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 Bah. There's a little bit. There's a little bit right there. There are my audio channels. I actually do have, I have a little chip that will, if pulled correctly by an Arduino or whatever, you need to pull it and get a digital signal out of it, and it sends 7 analog channels that give you a little FFT of what frequencies are coming out. It's a really cool chip, and I'd love to show it off to you guys at some point, but anyway. Yeah, FFT is a way at looking at the frequencies that are on a particular line. So what we're doing right now up here is we're looking at voltage over time, voltage per time. Voltage per time is a very powerful thing to engineers. It's a very powerful thing to engineers. We get to look at a signal in the time domain. The time domain. Welcome to the domain of time. The desert of the real. Okay, thanks, 14-year-old writer. The desert of the real. No, we're looking at the time domain, right? So as time goes on, you can think of this as like an earthquake-o-meter, just sort of scribbling away a signal, and it does that, and then it does it again and again and again. Now, right now, this signal might actually no, this one is not being manipulated. But when you you can incorporate a trigger into this in order to manipulate it in the time scale so that you can get it to line up with itself. And so if you have a constant frequency coming in on this thing, you can see that frequency. Or if you have a digital signal, you can see a digital signal. But if you take the different frequencies of this and split them out and plot it over time, you get what's called a Fourier transfer. And that's actually a mathematical function, but you could also do it like kind of, I guess, physically. What you're doing is you're basically extracting the different frequencies, because when you combine two frequencies, like you get two different frequencies on the line. You get the big wibbling one, and then you get the tiny wibbling signal on top of one another. So it'll shake up and down really quickly and do that also slowly, and so you get two different frequencies on there. So when you take an FFT, a fast Fourier transfer, what you're doing is you're extracting those frequencies and you're plotting them over basically, well, the time domain is just us looking at it, I guess, but the different frequencies are the different vertical slices of this, and then the horizontal axis is your strength. And so you get individual bands, because this thing is only looking at, you know, particular bands of frequencies at any given point in time. There are much more expensive tools to look at this, by the way. But yeah, if I do like the Mongolian like throat singing and just do you can see a couple different frequencies on that line. Now I can't do this loudly enough. Apparently this thing isn't allowing me to see much. I can only go down to 100 millivolts of these things. So channel 2 is pretty much maxed out. Oh wait, it just went way higher. Hold on a minute. Why is that able to go so much higher than it was before? All right, channel 2, keep your secrets. It's not affecting the FFT, though. What if I unit volt? Can I go to millivolt here? No. What is U? Watts? I don't think that's... No, it's not going to come out. It is volts, after all. No, not U. It's not helping me at all. I hit the wrong button. Math. Oh no. Oh no, what I was just altering the channel. Shit. Bolts, bolts, bolts. Okay, never mind. Math menu, math, FFT, center. Okay, hertz per div, center frequency, offset. We change the offset around here. How's that? No. Nope. Check, check, check. 1, 2, 3. Hey, these are the frequencies of my voice. Down we go. Negative 1.2 dBV. Are we getting anything out of this? No. It's not helping. Hertz per div. No, that's the frequencies. The center frequency is just where this thing sits. 1 kilohertz per div. I mean, I'm still on the charts. Oh, that's terminal voltage between the terminals measured. Huh. Channel 2. Let's bring that up into here. Maybe it's doing one of those things where it can only read what it sees. So unless I actually put this thing centered in there, it's not really gonna show now. It's hard to get, man. I don't know. Hard to see all this stuff at once. Math, FFT, 2dBV, scale. Here we go. There, that's at 100, 20, 50 dBV. Check 1, 2, 3. Ugh. Yeah, I'm gonna have to alter where the frequencies are, I think. Few half dBm scale. We're not resetting. Center frequency. Let's make that like 2 kilohertz. Do. Oops, it reset. Ah, this is getting tough. Why isn't this thing reading properly? There's probably a couple settings that I could do here, because I mean, we've got the offset at 1 dBV. There we go. There's our full chart. And I think if I take channel 2 and I put it back down to 100 millivolts. That's microvolts. Oh god, get it out, get it out. Not 2 volts. 2 volts is not going to show us anything. All right, 100 millivolts, I think, is where we found most of our frequencies, and I'm only kind of hitting them over here. You can see them just a little tiny bit. 1, 2, 3, 4. Why is voltage called U? Germans took freedoms and started calling voltage U because the letter was largely unused. Couldn't be confused with anything else. Came up with etymology used for Unterschied. Unterschied, which is German and means difference. Yeah, I guess it's a little bit more of a disambiguation of what voltage actually means, and so they're getting more to the point and being more specific and calling it something new so that it's not confused with other stuff. All right, so anyway, we can see a little bit of the frequencies here. It's not incredibly revealing. Oh. Unterschied. I need it pronounced. I won't be able to figure out what the fuck that... I can't do German. I'm so sorry. I don't know. Sometimes I'll try, and people say that I get it extremely close, and I'm always weirded out by that because I don't do it consistently. All right, so those are the frequencies. Now, what happens when I turn on my lights? Lights, desk toggle. Oop. Bam. Why is it getting less gain up at those frequencies? Huh. Nothing's really like sticking out to me, is it? Unless these are going in the negatives because of the offset. That's probably what it is. Hold on, let me go back to math menu. Math, FFT. Oops, no, we still on FFT. Please don't alter. No! Okay, 2 kilohertz offset. Whoa. Offset is 0. Well, even with offset at 0, it's like it's not a voice FFT, so it was pretty close. I don't know how I did it. Cheeto Bandito, thank you for following. Yeah, so we're trying to use the FFT function on the scope, which is a little bit slow at these frequencies. I could, if I really wanted to, I could probably set the center and the div to actually be a little bit better for voice. Narrow it down on the frequencies where we're actually seeing a difference in my beautiful voice, which we can barely see at this part of the chart. What I'm trying to do is at least ascertain a little bit of an idea of how much noise is being injected from my lighting, and it turns out it offsets the entire fast Fourier transfer. So this whole thing jumps up a little bit when my desk lights are on or off. Oop! Look at that. Oop! 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 I don't have a lot of control of this, so it's actually quite slow in doing this. But yeah, you can see that there's a. It's not really so much like individual noise. It's like every single channel gets that. So without that noise there, it's actually easier to see my voice altering these sections. Sorta, yeah, I guess it is white noise, huh? Maybe if we get my EQ adjusted properly with using that as white noise. I don't think I want to do that. I'm gonna try to get rid of that in the near future. Once I get all this stuff to do it tomorrow. So happy birthday to me. I get a bunch of ferrite cores and like an AC line filter. Yay. So, but yeah, anyway, what we're trying to do is we're trying to figure out how to get this EQ to work. And so the EQ, I think it's supposed to, what are the parameters on the input of this thing? So in order to figure that out, we need to go to the Elliott Sound page and actually look this thing up. And I think this is project 152. I think it's the first part of that. Yeah, 1521. 1521, which is technically it's a bass guitar amplifier, but we'll take a look and see what it says about. I don't have all the lights on here, so I don't look right. Bass amps are special. 4-string bass is a bottom E of frequency of 41, and the most 5-6-string bass is blah 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 blah. Great, cool. So this is like Fatanon's actually building this, but this is like a pretty nice analog bass guitar amplifier that you can build yourself if you have a ton of time and a lot of resources. There's a lot to this. There's a lot of different projects that are actually incorporated in this thing. You got a valve, tone controls, contour, distortion, compressor, and limiter. By the way, he has an optical compressor limiter on this thing. It's actually a photoresistor with a lamp on it. So you're playing the guitar, and all those frequencies that you're playing are being output by light and then picked back up, which is insane. LED, LDR. It's crazy. It's absolutely nuts that this would be able to, a light would be able to carry audio. I've heard of, I think it was some, oh wait, my go live notification was Oh Bothers Gaming. Whoopsies. Back at the bench. That doesn't really update anything, but I'll hit done on that. Put on an L. Wait, what happened to the rest of my title? What the fuck? What happened to the rest of my title? Why did that go away? It said put on an L. All right, whatever. Anyway, yeah, everything, all your audio frequencies go through an LED, which is really weird. It is shit seat gaming, isn't it? Hey, Groovy, how you doing, man? Stereo, biamped, digital, high pass filter, tuner DI. I don't know. It goes through all this stuff that I don't understand. And these are all comprehensive projects in and of themselves, each one. Each stage of this amplifier is like mega fucktown. It's crazy. So what we're really interested in is a good EQ, which would, I guess, be the tone controls or the whatever, the filters, whatever. It's all in here. It's all in here. So what we're looking at specifically, as I scroll down listlessly through this project, trying not to expose you guys to the sheer volume of text that exists on this website, I want to look for the individual filter stuff. Now, while it would be cool to use a tube amp on my audio setup, I don't really feel like having a tube burn my hips with a heater. It would be cool, but I'm not going to do it. Tube amps are cool because you have little heaters inside of them and they work on slightly different physics than everything else. But the problem is that you have little tube heaters on them. I mean, they like light up. That's the cool part about them. But They're not good for things you're gonna wear. So anyway, here is part of the circuit. That's not what we're using though. This is like one of the amplification stages, right? I would ask that if you have read every single word in this project, you just try to sit on your hands. I missed what the message was. Oh, I can show it. Yeah. We like to keep it to English here, unfortunately, man. Maybe you can punch that into Google Translate or something. So there's a couple different things going on here. We've got different controls for different frequencies. What we're technically interested in is the way that it's splitting out frequencies and enhancing them and tamping. I use the word tamping. I think that's the better word. For that, it's not necessarily the right word. I think it is. But this is the way that they're doing it with op-amps. We're not doing it with op-amps yet. I'll do that next. But first, we're trying to get the transistor method working. You see how these work? They have overlapping frequencies that they'll enhance or distort or do whatever on. Oh, it looks like Chatterino shows messages. It shouldn't do that. Hold on, I have to edit my Chatterino so that it doesn't do that. That's kind of important because I don't want blocked messages to show up on screen. How do I do that again? Let's see. General, chat, pause, smooth scrolling, show input when it's empty, show message length, sending duplicate, messages, show deleted messages, boop, okay. There we go. So now it won't from now on. Yeah, message was deleted. Here's the message. It's like, why delete messages then? For my own personal gratification, I need to see them just so that I know whether or not the... It's very rare that moderators will do anything to messages, though. You guys are pretty good. Okay, so anyway, that's what this is doing. That would be the I guess was that low pass or high pass? I don't know. But somewhere, I missed it. Maybe it's not 150. Is it the Wine Bridge? Yeah, no wait, this is not the one. This is the basis for what he's doing with the op amps. It's the graphic equalizer, and I actually have a different paint drawing that tells me which one it is. Project 149, that's what we're looking for. Wait, where are your fucking messages? Wait, where'd all the messages go? I cleared chat, but it should come back. Yeah, there it is. I had to pull this back up. 149. $149. I keep forgetting the other TT and stuff. Guitar bass graphic equalizer Mark II. It's hard to keep track of like what his latest and greatest is, and I wish I could get to his level where I kind of like knew all the tools that he has available to him and how to enhance and do other stuff to them. There's an interesting thing about the way he does stuff, where he will put out a project and have all of these different things that he justifies, and he says, you know, we need to have this op amp in this particular location because that gets rid of some of the transients and it keeps the Q. The Q is like the frequencies that it's working on, so like the band of frequency range that it's able to edit. It keeps that Q stable as you adjust the frequencies, because when you adjust one part of the circuit loop, it affects the other part of the circuit loop. Cylon Toast, thank you for following. Same with Cheeto I got Cheeto Bandito and Blackberry Jam Studios. I forgot to say thank you for the follow. So yeah, when we have the different ways that Elliot is putting stuff together, you start to get into his head. He's got his initial blush at the project where he takes some like older stuff that people have worked on previously and sort of builds upon it, and he does a lot of very advanced filtering and stuff with the thing. And he's, you know, it's like, I've got to put this here to keep this from drifting when we adjust it, because when you adjust one part of an analog circuit, you're adjusting every circuit loop as a result. It's ridiculous when you get down to the nitty-gritty of this stuff. Then he will go on to incorporate that project into another one of his projects, but it's a much simpler circuit. When you get down to what he's actually saying in the text, he's like, oh yeah, you'll never hear that if you put that extra op amp in there. And it's like, Elliot, Jesus Christ. Like, he does all this stuff. He like super refines it for the one project, and then he'll go back on a lot of this stuff in the other one. And in fact, the circuit that I use to build the mic pack that I typically use, Project 93, which is this part of the circuit right here, he doesn't like this. He likes the one that just uses transistors. I'm using op amps, so I don't know. Audio is subjective. I'll tell you that right now. Audio is subjective. There's no one way to do it. I do what I do because I do what I do. That's it. That's it. That's all, the only justification behind it that I ever need. So anyway, on with my babbling. This is Project 149, and it comes before Project 152 numerically. In 149, he lays out a little bit of an op-amp circuit that would do what's called a graphic equalizer, which means every part of the circuit gets every part of the... Why isn't my chat freaking updating? Why do I have to have it? I guess if I minimize Chatterino, it doesn't do it. Yeah, nobody will notice a difference, so you don't need it after you read like 60 pages of an article. But okay, so this is a graphic equalizer. So a parametric equalizer gets okay. In a parametric equalizer, every part of the equalization, each step of the way, gets the whole signal plus or minus whatever the previous stage did to it, right? Whisper down the lane. It's like a series circuit. A graphic equalizer, this is just the amplification of the graphic equalizer. A graphic equalizer gets each stage of the equalization, gets the entire audio signal and pulls out a little bell curve of it and then joins it all back together. And I'm not skipping parts, I'm just going to this chart right here. This will give you an idea over a range of frequencies. Remember, we're in frequency domain. We're not listening to a signal over time. That's what maybe, it's not really what the combined response is in frequency response. So this is what happens basically in the Fourier transfer. If you look up, oh, I have a band here, I look it up on this table, it's here, that means it's this much higher, this much lower. This is how each stage of the filter affects it. That's a graphic equalizer. And so that's what we're trying to build right now. I've put this whole circuit to actual physical stuff, and we're going to try to get this working with the rest of this thing. Now, right now, by the way, all of my audio that I am giving to you guys right now, all the talking that I'm doing is going through this right here. So this thing that I've haphazardly built onto a a solderless breadboard, this whole filter is actually what you're hearing. And so if I screw around with it, you guys will be getting some weird stuff going on as I touch and manipulate all this stuff with like my finger grounded all the way. Ooh, I got a little buzz from that. You know, that's gonna affect stuff. I don't know what you guys heard on the outset there. Did you guys hear all kinds of weird effects going on it as I did that? Because I mean, the galvanic resistance of my skin will actually affect this stuff. You got a 60 hertz buzz? Yeah, probably because my leg is hitting the desk. Buzz on the op amp? Yeah, it'll do that to you. You'll get a little bit of buzzing from something like this. All right, anyway. But yeah, so all of my dulcet tones are going through this sort of like, how do I explain this? It's like a nature recording kind of thing. This is a very one-to-one kind of amplifier. It does a really good job of reproducing all of the audio frequencies that exist in space. You guys get the benefit of hearing it through the filters, and so we're going to try to externalize one of the filters and get that running with everything else. But here's the deal. I need to check over this circuit, and I need to get this part of the circuit running, and then we need to figure out how exactly we're supposed to be plugging this thing in, because what we were doing before wasn't precisely working. There's a couple different methods that I could use to get down to the nitty-gritty on this. What I could do, I'm thinking about what exactly I want to do. I could take one of the frequencies of this circuit, like I could take the center frequency of this circuit, and I can inject it where the microphone goes, and then I could isolate out the audio over here, move back to my other mic pack, and plug this into the Focusrite separately, so that I'm getting phantom power into this part of the circuit, and we can observe what's coming out of the output, and it won't affect what you guys are hearing. I think that's probably what I want to do. First, I'm going to go over one for one this part of the circuit and just make sure that I built everything correctly. Then we can isolate out one of these, choose the frequency, inject it with this, and that'll be at a 5-volt offset with 100 millivolts peak to peak. And I actually did testing on this yesterday because you guys didn't have to hear the audio output. It would have killed you, but it comes out to right about here on the compressor. So it's at a 5 volts with 100 millivolts peak to peak, puts us at my yelling voice. This is when I talk emphatically. And I would like to be able to talk like this when I'm gaming, but I think my roommates might call the police if I'm screaming too much. If I scream like tomato, I think I'm going to get the cops called on me. But I have an audio setup where I could do that, and I would like to in the future. Like that one time when I fell down the cliff in Satisfactory, and I was like, oh no. It sounded like shit. I should have screamed. I should have actually screamed. Because it's much funnier when you actually put a little bit of volume into what you're doing. But I don't, I don't exactly have padded walls in here. Okay, maybe I do, but still. All right, I gotta go pee-pee. I gotta go to the bathroom because I drank a whole Red Bull and my glucose levels through the roof. One of the things about glucose levels is that when you're hyperglycemic, your kidneys go into overdrive in terms of filtration, and it's good to feed them, but that means you need to pee a lot. Loud equals funny in the PewDiePie law. Listen, it's not about loud as well. Okay, it is loud is equal to funny, except that I'm not being loud because I'm going through a compressor. You guys aren't going to get loud. You will just get the vocal, what do you call that? The vocal, not tinge, verve, vocal rasp, not inflect. It's the, there's a word for it, but I can't figure it out. Yeah, maybe a little bit of the vocal fry of me actually screaming, which is hilarious. I like it when it's compressed. The problem is I've had people in the past go, "Bother, your audio is amazing. How do I get the same audio out of it? What microphone do I buy?" And I go, Audio-Technica AT2020 Plus, because you can plug it directly into your computer. And then they get that, and then they have just that microphone going into OBS, and they go, ah, and then you go, because you're getting like maximum audio out of the channel, and it distorts. It's bad. You shouldn't be going into the red. You need a compressor on your setup. They do this a lot in like Red Letter Media back in the not Red Letter Media, because they put everything through Adobe and then they equalize it at the end, which does the same thing as a compressor. Not clipping. Well, yeah, clipping and stuff like that, but prereq. No, because when I hit the red occasionally, people say that I've got terrible audio. Not getting, you can virtually clip the signal where you're not clipping, but the waves are cutting off. And so you get the same effect as clipping without blowing people's speakers up. It's actually kind of funny. Lawrence was upset. Lawrence from, well, he just streams now. Sir Lar was very, like, he was like obsessed with that effect for a little while, and it showed in his editing. But yeah, the thing is, like previously recorded live, they had Rich Evans on a microphone, which is not a mistake, but it's hilarious. Rich Evans on a microphone. Rich Evans has a very broad dB range of his vocals, including very high frequency, very loud noise. The thing about Rich is they've tried everything with his laugh. They've tried, you can mute him and his audio still comes through at full volume for some reason. It's supernatural. But what we suggested as chat, just sort of listlessly trying to suggest things to these already professionals, we were like, please, oh please, oh please, put a compressor on him. So Jack bought this semi-pro rack mount compressor, and they tried to put it on their audio. They didn't get it configured properly or anything like that. The filter that I've got right now is probably something that they should give Rich Evans, because right now what happens is if I start like screaming and hollering, I've got a cutoff that I'm not going to get over in terms of loudness. So while I'll get louder and louder, which I'm not going to do because I don't want to ruin my voice right now, I'll get louder and louder. This will get softer and softer suddenly. And I do this for Power Tools. Power Tools and Rich Evans both should get this kind of filter. But yeah, that's my own specific broadcasting filter. Yeah, you guys are benefiting from this right now. But what I would love to be able to do is scream into a mic and have that vocal rasp and not blow out your speakers. That's very important to me. So I've got to replicate that inside the mixer. I've suggested to people to use the microphone that I use, but they don't put in the work to come up with a compressor like this, or to frequency filter an already pretty nice microphone. I'm actually thinking of getting a new microphone for my desk setup so I don't have to wear the lapel while I'm streaming games, and then I can use the mixer with that. So I'm thinking about that. Okay, PP, I'll BRB. So let me BRB for PP. BRB PP. What am I doing for that? I do setup. No, not setup. Sorry, overlays. And then I activate the go to the bathroom overlay. That's not. Let's try that again. No, that's RuPaul. RuPaul, what are you doing? What is this? Spooky month is over. You're not supposed to be. No, what are you doing? Oh my God. Oh God. Oh God. All right. What the hell was that? All right, I'll BRB. Let's put on other music though. Check out the stream from 13 years ago. No, we're not. We're not looking for saturation. I was just trying to explain why I have all this audio work on my mic. Because the mic is it's reproducing sound very accurately, but there's nothing going on there in order to make it a little bit more pleasurable for broadcast. And actually on radio stations, you really need to limit the amount of audio that you're putting out. Now, radio stations aren't analog anymore, but back in the days of analog radio stations, if you did not have a limiting compressor on your audio output, you would actually blow out into sidebands of the radio. See, the reason radio stations are so separated in the age of analog electronics is because originally you actually had frequency modulated audio. And so as the frequency went up and down, so as you went out to the side bands of the band that you're listening to, that would mean that the signal's getting louder or softer, sort of, in a way. You would take a frequency and then you would add it to your audio with like combining electronics, and then that would be the frequencies that you would output from the radio. And so you would have a band that you could stay within. And if you went outside of that band, you would get fined. Hey, thanks for stopping by, man. Congrats on the gift sub. Yeah, we're gonna try to get something that we want out of the EQ, but we need a way to oh god, I can't move from the desk. We need a way to characterize the signal. I hope that didn't alter the audio too much. I just pulled away. I need to mute because I'm trapped to the desk right now. Actually, I'm gonna get off. I'm gonna get off. Let me put back together my other amp so that I can go get a drink. I'm gonna put back together my other amp, and then we'll. I wanted to flex on you guys by having all of my audio going through the perforated prototyping board. But now that we know the audio that's coming out of this thing, and here, let me turn off the math menu, and let me just get a. Let's get an idea of what the signal is coming out of this thing. Well, actually, I kind of already know. I already know what's coming out of this thing. So, without the desk lights on, this is at 100 millivolts. We can turn channel 1 down to 100 millivolts. But then we have to turn the coupling to AC because I can't deal with the offset. Hello? Oh, ground couple. What are you doing? AC coupling. All right, there we go. So now we can see the audio, and you can see how the two pieces of audio coming out of the two pieces of the filter. I love this. This is one of my favorite things to do. This is some of the first stuff that I did with an oscilloscope, was take the output and put audio through it. And you've got 1 volt peak to peak on your line audio voltage. This is about in the span of 100 millivolts for my typical volume. You can see here that I've got it set to 100 millivolts per div. And if I move, let me move this one up a little bit. See how when it pauses, they are exact opposites of one another. The reason channel 2 is so dirty right now is because we don't have a local ground. Let me put a local ground in this, and you guys can see, it'll clean it up a little bit. By local ground, what I mean is that this probe is going through a cable, and it's picking up noise everywhere. That is what I want. I want a ground that's right on this, and that'll help filter out a little bit of the noise that we're hearing. So I gotta get back here. I had to find one of my ground clips. I sort of did. Where is it? Where'd it go? Here we go. These little ground clips. You gotta keep these, all the scope accessories, all the scope probe accessories. You can buy more scope probes, but listen, when you actually need it, like, these things are worth their weight in friggin' myrrh. They're worth their weight in special super gold. You gotta keep these, you gotta keep track of these with your life, because nobody else who uses the lab bench will keep track of it. And I can guarantee you that, as somebody who's worked in several different lab environments, everyone else is a complete numbskull when it comes to fucking keeping the implements of your actual test and measurement supplies together. There's no exception. So yeah, now they're both grounded, and look at how much cleaner that signal is. Beautiful. So yeah, local grounds for the win, I guess, in this, since we're dealing with a slightly noisy environment. What I need to do is I need to actually move this over. I need to move this over. Now that we know approximately what this signal looks, like. On the AC band, 100 millivolts per div, or plus or minus 100 millivolts. And this exists on an offset of about 7.5 volts, I believe. Isn't the oscilloscope directly connected to ground? Well, you gotta understand how that ground is getting there. Now, the oscilloscope is very accurately measuring a difference between whatever this signal is and ground. And so when I have this on AC coupling, it will ignore the DC component of this signal. Now, these are both at an offset of about 5 volts. I guess that's what the virtual ground is doing. They're at an offset of about 7.5 volts, let's be honest. At an offset of 7.5 volts, and it's looking at AC, but the AC is still compared to an actual grounding on this thing, because it's an offset virtual ground DC kind of a deal, right? So when I ground one of the probes, it goes to the oscilloscope ground, which is a shared ground. And so it'll take that as a reference offset for everything else. The problem is this probe is a coil of wire, and it's a coil of wire in the presence of some LED lighting, which has some very hard switching apparatus in it, which causes a lot of noise. And so to get rid of as much noise as we can, giving this a more local ground where to dump its excess electrons helps it. And so demonstrably, we have less noise. I mean, you know, I don't know what to tell you, because this if I remove this ground, we get a lot of noise on that signal. It's still functional, but we still get a lot of noise on that signal. Yep, it's the probe wires. It's the coil of wire that consists of the probe picking up RF. It's pretty crazy. It's pretty crazy the amount of noise that can be filtered out just by grounding. And actually, these probes, if you take the hat off of the probe, you can take the hat out of the probe, but you can't take the probe out of the hat. What? If you take the hat off of the probe, there's a little pointy end, and then there's a collar down here. And I have accessories that are basically a spring that contacts the collar and gives you an extra probe. And what that extra probe does with the little springy thing on it is it gives you a more local ground in order to test RF circuits locally. Sometimes in RF circuits, you'll see a test pad, and then you'll see a ground pad right below it. And that's for that system, where you put the little spring on the end of the probe and then boop, probe right to it. All right, let me put my audio stuff back together so that I can actually wear the mic pack. Wear the mic pack. What the dog doing? Okay, so this needs to go like that, and then yeah. So when we design this part of the circuit, it's probably going to be so tight that we're going to need to have 2 circuit board layers on this, which makes these connections that much harder to do. I don't know how I'm going to be able to do it. Having both of these be a couple millimeters thick will give me a little bit more space for a circuit board, and hopefully the amplifier that we're using isn't going to be too large. Maybe we can fit it all on one circuit board. Yeah, you could absolutely short everything with one of those local grounds. The lab assistants keep telling us that grounding it is useless because it already is. Well, I mean, when you're dealing with higher frequencies like audio and RF, I mean, you saw right there that we got a clear signal by grounding both of them. Typically, I do not do this. That's why I had to get it out of the drawer. If we're doing 5-volt digital stuff, it doesn't make much of a difference. You're not going to see all that little tiny bit of noise. Although you do see a little bit of noise on the line, I need to filter my lights for that. Yeah, I think I'm going to have to do double-sided. I'm afraid about noise with double-sided circuits, because then you can have audio lines that aren't crossing at a 90-degree angle. That could be problematic. But I'm going to have to do it. It's going to have to happen. I don't know how I'm going to get this aligned. I can keep that in place. Nope. It's like the circuit board needs to, I need to undo one of these ends so that I can get the circuit board in place. No 4-layer boards. Possibly smaller op amps. I don't know. What I'm annoyed about is that we got to break this down. I like having my voice on the O-scope. Look at how clear that is. That's super awesome. Every single frequency of the things that I'm telling you about is available in both inverted and normal mode. Yeah, I could use much smaller electronics. I could use a multiple transistor chip too if I really wanted to. I don't know if I'll go maybe quad op amps. The noisy light, yeah. Setup, lights, desk. It's still there. Look at all that garbage. Why does it affect channel 2 more than it affects channel 1? They're both 100 millivolt peak to peak. I do not know this. They're both plugged into the same ground. See, what I need to do is jiggle the circuit board so that this clips together. Jiggle the wire. Yeah, no, I'm glad you reminded me, because that's a good test. Oh, wait. Comes and goes. What, have you wrapped all your light drivers in foil? I don't know, man. Listen, the ferrite cores are gonna significantly alter that. I have a feeling some of this is feedback from the power line, and then another component of it is just RF that's sitting around in the air. So the ferrites are supposed to get rid of that. They're both on ×1. Probe 1x. Back together. All right, so back on the other amp that I can clip to my belt. We're back on the circuit board. No more stuff going on here. Now I'm gonna have to get my other audio cable. I'm gonna have to plug that into the 2i2 so that we can get phantom power out of it. I want to use phantom power from the 2i2 because I want to know, like, I just want it to be there, and I don't think I have a virtual phantom power thing. I'm not spending any more money, so so I'm gonna use phantom power from the thing that produces it. Yeah, you're allowed to curse. Listen, Twitch isn't. You got to be at least 14 years old in order to use Twitch, and so that's pretty much the humor level of a lot of my audience. I curse a lot. I try not to, a little bit. I've gotten, like, I tried to get a sponsor from a very popular motor controls company that makes some really cool stuff, and they're like, we don't really like that curse in your Burn the Subs video, and I'm like, meh. If you're only 7, then you shouldn't be on this. You shouldn't be on Twitch. It's gonna rot your brain out. It's gonna rot your brain completely out, and then you won't have a brain, and it'll be very tragic. It'll be very tragic. Where did my other mic cable go? What did I do with it? What did I do with that other mic cable? That should be around here somewhere. I don't see it anywhere. What the fuck? Wait, what did I wait? These are like critical audio. These are critical components to my setup here. Having spares is like sacred. I had it out the other day. What did I do with it? Oh boy, I gotta find my other audio cable. This is an important piece of the whole thing, especially for today. I don't see it anywhere. What the fuck? What did I do with it? Uh-oh. You know, maybe I put it back in this drawer. Not in the drawer. Maybe in the drawer below. Not in the drawer below. Oh, interesting. What the fuck? How can I lose an entire audio cable? Wait, why am I plugged into number 2? I should be plugged into number 1. Oh no, I'm plugged into number 0. That's right. It goes 0 and 1. Oh, there it is. It's on the fart box. You guys have been hiding it. This is your fault, chat. It's entirely your fault. I blame you. Almost exclusively for all of the shortcomings around here. All right, so that's our other audio cable, and that's what's going to give us phantom power. So if I screw up hard enough, you might be able to hear it over the audio system, but... So this I'm just going to neaten it up so I don't trip over it. Got to get all the twists out of it. I really need to finish that rack mount computer. It's sitting right here. What an asshole I am for not finishing all of my projects in a day. All right. This is still like all coiled up all weird. It's really annoying. Can't do much about it right now. I'm just going to coil this up and then I'll get something to drink because I got to keep the liquids going because I'm hyperglycemic. Got to keep my kidneys clean. It's actually very important for the diabetic. All right, there's our test cable, and then I'm gonna get something to drink. Probably not Red Bull though. I got Diet Dr. Pepper. I don't know. I don't think that's really healthy for me. Oh well. That glass look dirty. I'll use it. Oh yeah, that's all foam. That's all foam. That's all foam. All foam all the time. Oops, all foam. New soda. All right, so what we'll do is we'll plug this thing in, and I will inject a 2 kilohertz signal into it. Actually, 3. We'll look at the frequency that we've sort of tuned this thing for, and we'll see where it falls on the grand spectrum of things, right? So let's take a look here. That's metronomic. That has nothing to do with what we're... So what we have is a failure to communicate. What we have is this circuit here, right there. But we have different frequencies. He's showing all, what is it, 9 bands or whatever of ZQ here. We're only going to concentrate on one today. We're going to take this in baby steps. And this is what I always say about these kinds of projects is that, you know, sometimes I bite off a little bit more than I can chew. Sometimes I'll go for the full, I don't know, just try the whole ensemble at the same time, and you know, little tiny pieces of it won't work, and that'll take everything down. And that's what we ran into when we did this on a week ago. Is I built 3 of these. No. There's a I was gonna, I think it was a musical term. Is Full Monty a musical? I don't think it is. This right here. I built this 3 times. We selected 3 frequencies that were kind of a reasonable spread of frequencies that you would get out of audio. I tried to pipe all of my microphone audio through it, and we had troubles. We had troubles with the Stop it! I've moved on. Fuck! I have to stop thinking of. Okay. We tried it all at the same time, and it didn't work. And there were problems with the microphone amplifier circuit. And I have revamped the mic. I have not really revamped, but I did corrections to the microphone circuit in order to get it up and running. Now we've got to check over this part of the circuit, and we have to make sure that this is what's represented there. Now keep in mind, this part of the circuit is built for different purposes. This is for a guitar amp, and there are different things available to the guitar amp than there are for the microphone, for the Electret microphone amplifier. See, what I'm trying to do is make a full, like, I don't know how do I describe it? I guess like it's not like I make it like into a condenser mic or something. Maybe I was looking for Kit and Caboodle. I don't know. This has a positive virtual earth and a negative virtual earth. It has a filter in and a filter out. My experience with okay, hold on. Come back down here. My experience with the Elliott Sound projects and the way that he's doing these positives and negative is that the positive virtual earth is being used in the same manner as the power supply for the op-amp. See, I'm seeing that right here. Negative virtual earth is 100 nanofarad, a 100 nanofarad capacitor away. If that's the case, our virtual earth from the other one is not the same. We are not the same. I've seen that meme lately. We are not the same meme. They're not the same, because I figured that this was virtual earth right here. This whole 7.5 volt nonsense that's going on right here. But in the case of that other, the guitar amplifier, he's taking virtual earth as just like something off of a capacitor. So that would be the virtual earth. But that's off of a line that's already biased in a particular direction, so it doesn't really make much sense to be in this circuit. We can play around with what we get and see what we get on the outset of that. Sorry, those are all parts. Let's go back over here. Sorry, so this is just the few projects that I'm getting inspiration from. Project 152 is going to be our next attempt, by the way. We're going to try it with op amps and see if it's better. My only problem with 152 is that I need a dual potentiometer, and I need to order a couple of those. I don't know where to find them. Fucking meta. So dumb. All right. Look at us. We have a different name. Why'd you make all the news cycles? It's like with Amazon and drone delivery. Like, as soon as a scathing report came out about Amazon like seriously mistreating their workers in their factories. They're like, we're going to do drone delivery. And all the news articles are like, ooh, tech article. Let's talk about how drone delivery is going to be the next thing. And everybody's like, what about these people who have to pee in fucking bottles? Like, they're not even treated like humans. They're given a little pad and they have to go to a certain part of the factory with a timer on the little electronic pad to scan the thing to make sure that they got it and they can run it back. And they have people like running to different parts of the factory and their paths are plotted out digitally. You are literally just following the path of a robot. It's absolutely ridiculous. Anyway, 0.1 UF is our first circuit, and that's 226 hertz. So we could take 226 hertz and check that one out. 1028 is a little closer to what I tested. Let's do the second piece of the circuit. So we're at 1028 as the center frequency, and we want to pump that into this circuit and make sure that we get it out on the other end, and that we can actually plot all that stuff. Dion Starfire, 8 months, thank you. So 1028 hertz. We're going to put into this part of the circuit here. We're going to connect this to our phantom power, which is 10 volts, which I guess I could give it 10 volts. I could just give the circuit 10 volts and try to get that out on the other end. But let's just do it this way, though. So 1028 hertz, we're going to inject into one part of this, and then we have to figure out what virtual earth is going to be, if that's going to be the offset of 7 volts or what that's going to do. And then our filter output, we need to plug back into the amplifier circuit in order to get the right gain. So first of all, let's pump the 1028 hertz through our original setup in order to get that right. I said we do analog audio, we're going to do analog audio. Oh yeah, before we do that, I need to check over my circuit to make sure that it's correct. Maybe we'll do that next. We'll do this first. We'll do this first. So get that out of the way. So I have here the second channel of the Focusrite 2i2. Why did this? Oh, did I turn that light off permanently? Yeah, let me turn it back on. Need that light on so we can see what's going on. This is the second channel of the Focusrite 2i2. Since I didn't install the 2i2 software, I don't know exactly what that entails. I don't have this on an individual channel. This is the same channel as the one that I'm talking to you through. It also has phantom power on it. So what I'm going to do is I'm going to cut off audio to these channels while still being able to use the phantom power. And I think the way that I want to do that is by moving the 100 ohm resistor over one slot, and then we'll pick up that 100 ohm resistor on the oscilloscope. So what I'm talking about doing, and remember, our circuit, to put it very simply, right? Now, chat, hold on one fucking second here. Before I get into this, I am going to be talking in generalizations. I do not need you to confuse everybody else by getting way into the specifics of what I'm talking about. We're taking this as an overview, and I'm checking over my work. And the whole point of this is that I'm checking over what I've done previously in order to make sure that the overall large components function together. So what we're doing is we're taking steps back and we're taking a look at what the inputs and outputs of things are. We verified that the microphone signal is exactly what is there before. Now we're trying to modify things, but we're not going to get caught up in the minutia, right? So when I go through this circuit to tell you guys what's going on, I'm trying to get new people up to speed. We're not going over the minutia. Capiche? Capiche? All right. Okay. All right. People are still going to do it, and I'm just going to ignore it. So I hope nobody gets insulted that I ignore them. And if you do, tough cookies, because that's the way we're doing it today. So we have an electret microphone, which is a little piezoelectric device that creates a little wibbly AC line. It's about 50 millivolts out of this line right here. It's actually around 100 millivolts if you really scream. So that positive mic line has a little bit of a DC offset and then a little bit of a wibbly voltage on it, right? And so what we're doing is we are filtering that out with a capacitor, because that 10K resistor is there in order to power the electret microphone. What we're doing is we're putting it through an electrolytic capacitor, which is a positive and a negative. that's going to get rid of the DC component of the signal. So now we just have this wibbly line existing in AC. With that wibbly line existing in AC, we also need to create a virtual voltage offset. So it would be, I guess, a voltage divider between these two. Whatever. Either way, there's about 7 volts sitting on this line, and I guess we're adding to it a little bit of this component here. So we're pulling it up to around 7 volts. And then we do a little bit of comparison through an amplifier, and that amplifies the signal to about, it probably should be about 1 volt peak to peak, although we kind of measured it as being like 100 millivolts peak to peak. 100 millivolts peak to peak. But that's still going to be at an offset right here. So 100 millivolts peak to peak. But then there's this DC component on the line and an AC component on the line. This exists at about 50 volts, about 48 volts, both of these lines, which is common mode. In an audio circuit, in a microphone circuit, you need to have differential audio. So one wave exists like this, and the other wave exists like this. And that way, if you get noise on the line in the form of a spike, you get a positive spike on both ends or a negative spike on both ends. And that gets filtered out. And so these spikes that exist on both lines, that one and that one right there, see that spike existing on both lines? That gets filtered out. That's why I can have all of the noise from my lighting on this line, and it gets deleted from your audio. That's the beauty of differential audio. So because of the beauty of differential audio, since we have a 100 millivolt signal on this line, we are able to get clean audio. But the problem is, if we have an AC component on our power supply, that's going to cause weird stuff to happen in the op amps and with the differential circuit, with the virtual earth and all that. So we have this little transistor circuit right here that is going to delete my audio from the line while allowing 50 volts, 48 volts out here, and then limiting it down to 10 volts. It's really weird. Analog audio is really, really weird. What that means is that we can have phantom power on this microphone pack, and I can still run a lavalier microphone. That's the specialty of my own audio. I don't, usually you'd have like a DC audio circuit running a lavalier microphone into a wireless pack that would then go into the computer. But if I put you guys on a wireless pack, you'd hear me taking a poop during stream, and I don't want that. So I have it on a wired lavalier pack, and I'm able to get near professional audio out of a circuit like this. So our task is to now filter this and take this thing in component blocks. So in terms of component blocks, basically what we got going on here is we have a signal coming in here. We have an offset that we don't need to think about that is then not really deleted. I guess the offset is still, well, it is deleted because the DC component is deleted right here. So the DC component is deleted, and then we have an AC component coming out of here, right? This amplifier's job is to create the opposite signal that's on that audio line. So with the two amplifiers split out like that, I can put our circuit in right here. So what I want to do is I want to inject, basically put an audio signal here, and then we can look at what comes out on the other side. So according to the testing that I've done on Monday, I am able to take, by the way, this thing is a fun little kit. We did this as a soldering kit many, many moons ago. I think only Celia Russell and Leb were around when I did this. But this little frequency generator, I didn't have any use for. We finally do. Copyright 2015. Jesus Christ. So right now I've got it outputting a 2 kilohertz sine wave at 100 millivolt. I think that's peak to peak, I'm not really sure. And then it's got a 5 volt, it can't do any more than a 5 volt offset. So we have a 5 volt offset, and I could probably tune this circuit to work with a 5 volt offset, but so yeah, we have a 5 volt offset and 100 millivolts peak to peak. So in terms of the way the amplification circuit is dealing with it, it should be getting rid of that 500 millivolt, or sorry, the 5 volt offset. It should be, the DC, the capacitor should be filtering that out. So what we'll look at is an injected signal. Actually, with 100 millivolts peak to peak, I can put that in here. Well, with a 5-volt offset, I should put it right here. So I can insert that right there. It will not have a 7.5-volt offset, which might affect the gain. I could also put it in here. Well, with 100 millivolts, that actually, because I don't think I can do 0.5 millivolt with this thing. I'd have to get different instrumentation in order to do that. So I would like to incorporate that part of the circuit and everything, though. Let's see what comes out of the other end. We probably should have captured another audio signal, but yeah, let's okay, so we'll do that, and then what I'll do is I will cut off this and this, and that's where our probes will go. And that way we're not outputting audio to the rest of everything else. I mean, we are cutting off the filter circuit, but we shouldn't need that filter circuit. That can just sit, and then this will sit at 10 volts, and there's no analog component on our DC delivery. So that's easy to do. That's easy to do. Ugh, my perforated my breadboard is it's a little sloppy. It's a little sloppy. But yeah, there's our amplifier. We got one amplifier on each side. That one's the initial amp, which I probably should have actually flipped this around, to be honest, because I think it would probably perforate solderless breadboard more easily. But down here is where we have the resistors. Now, I didn't have 100 ohm resistors. I also don't have my tweezers. Where are my tweezers? Are they on the floor? They are on the floor. I dropped them a while ago. Let me get my tweezers off the floor. Herf the floor. Is that frozen? Is that camera frozen? Yeah, it is. Hold on. Unfreeze the camera. Properties. Deactivate. There we go. Look at how warm my scope is. It is quite a warm. It's quite a warm scope. It has a. It creates a bit of heat. I put an Octojay fan in it, which is currently running. By the way, if you buy this Rigol, it's loud. They don't do a lot to isolate the vibration of the fan. So it helps to get an Octojay and a bunch of double-sided foam tape in order to properly mount a fan a little bit away from all the grating that they put in the way, and then you get decent airflow and it's quiet. I needed that for broadcasting because I didn't want to have this audible at all times. So yeah, in order to cut everything off, what I need to do, I mean, I could just move these wires. Let's just move these wires, because what these wires are doing are taking it down to the transistors where it gets filtered. So if I simply take this wire and I just move it to delete audio from our path, then we will have isolated the audio away from what you guys can hear. Oh wait, but no, you know what? No. Instead of moving those input wires, because yeah, I still need these to connect to that area. I could actually connect these down here, but according to the way the circuit is, god damn, I am just made out of hair. These are head hairs, you can tell. Why are they all over this board? Get out of here. Gotta pick away all of my friggin' pubes from this board. Okay, my face pubes. Oh god. There we go. A little cleaner. Okay, so what I need to do is take this. This is the scope probe, and this is the audio output. So I am going to take my audio input, and I'll move it down one row. Shut up, sausage toes! I don't need your sass. God damn it. You guys can't. I did this as a joke, but yeah, chat has just moved to. Actually, the chat's in the wrong place for the joke to work. Where's my... Oh, there's my hand. Vsauce, Michael here. Where are your hands? I don't know, Vsauce. What did you do to my hands? My age is 17 months. Oh, hell yeah. Well, thank you for the 17 months. I know it's very sudden, but... All right, so let's move the second channel, the second differential pair off of this. I had to combine two resistors in order to make 100K. It's about a 109K. But that wasn't what was affecting gain, by the way. Our gain was very low in the previous circuit, and that's because one half, like the inverting part of the amplifier, wasn't even functioning. All right, you little bastard. This wire's in the way. Get out of the way. All right, so what I want to do is just bridge that straight over. Yeah, 17 months is awesome. Thank you so much, my Aegis. I really appreciate it. You guys who are subbing, like in the interim, when we don't have the board working, have done a lot to alleviate my concerns with the fact that I am a gimmick channel. I'm a gimmick channel, guys. I hate to tell you that. But, you know, we have a physical board that burns names of subscribers onto itself. That's a big draw for a lot of people. It's the only reason that I'm in the top lower 10,000 for number of streamers. So you got a Raspberry Pi Pico? There's a new one, right? All right. Or no, that's the Raspberry Pi Pico is I haven't found any use. I have so many of them. I've got like 5 or 6 of them. I don't know what to do with it yet. Now I want Pi. I just don't know. I don't know what to do with this thing. I don't got any good projects for this thing. I don't know what I could do with MicroPython or whatever the hell. I want to build a keyboard. I like my keyboard. Yeah, but just because something's cheap doesn't mean you need to use it. It's so cheap, you can't afford to not get one. Just because you're doing a keyboard, I'm not going to build a key. It doesn't mean everybody... Okay, I'm going to plug this into phantom power, and hopefully we don't cause a shit ton of noise. You run Rust on the... Oh, God. I'm doing Ruby on Rails for physical computing. Uh-oh, that seems to be a lot of noise. Did it go away? Yeah, I actually do have a Model M, too. It's sitting up on the shelf. There he is. There's the IBM Model M. I could probably turn that into a real keyboard. It's a real boy. So we got a little bit of noise. It seems to have settled down. So we shouldn't be able to hear anything coming from this, but we still got power going to everything. But wait, I can't even like suss out that name in time. Emulsionist. Immolation arsonist. Emal arsonist. Thank you for following. A two derivative word. All right. Close enough. You know, I do what I can. Oops. So yeah, we've cut off audio. Oh wait. That's where all the noise came from. That's, oh wait, no. We want that. Sorry for the pops that you probably got just then. A larcenist. Oh no. All right, so part of this circuit is actually functioning. An update on BTS 3. BTS 2.5 is taking preference for that. I haven't worked on BTS 3. BTS 2.5 is taking precedence to get this thing back up and running. I got a piece of live edge board from Lytton, Pennsylvania, and it required me to widen BTS 2.5. So while we're widening it, I'm actually working on a 3D printed laser head, which is going to use a much better laser mount than what I had before, and it'll just be a little bit more organized and presentable. And so I've done a little bit of, well, a lot of work on that. I'm working on 3D modeling the 3D print for it, which is a larger piece than I normally 3D print. We're going to work on that on Thursday, right? On a 5-watt blue laser module that I got in my junk box. No, I don't, because I don't want to. 1.4 watts is very specifically chosen because it's enough that we can get a good burn, and it's little enough so that I don't have to wear laser goggles. Higher wattage lasers might be possible for BTS3 because it could move a lot faster. But Fluffy Pink Llama, thanks for the sub. Yeah, new board. Who dis? Yeah, I'm not gonna. No. But yeah, I still need to wash out the reservoir on the actual control board. You can see all the scaling or whatever it is, the water line stuff that's left in there. And then we need to devise a way to plot out the edges of this board. So we'll need to get into Python a little bit and create some kind of a specialty program that'll allow me to trace the edge. Yeah, this is an expensive piece of wood compared to what I used before. I think what I used before was like $100, and this is several hundred. So, did you move the blue audio line along with the resistor? Not sure I saw that right. Hey, let's take a look. Did I accidentally do that? I did. Oh, that was dumb. Okay, I'm gonna mute for this. Yeah, never underestimate the eagle eyes of viewers. Okay, so now the audio lines are fully isolated. No, I'm pretty sure I can come up with the code on my own. I'm pretty confident about that. So yeah, anyway, our probe lines are still on the right things. Our probe line here is going on the output to that audio. The other probe line. Hey, Uncle Phil, thank you for subbing. I appreciate that, man. It's mighty nice of you. For 5 months. So, this is where we're taking our audio out from our circuit, and then we're going to manipulate it, and we're going to put it on here, and this is where one half of it gets inverted, and then the other half, see, there's the line that goes out to get it inverted. This goes up into an op amp, gets inverted, and then gets put out on this line down here. So, excuse me, hold on, I'm gonna cough. So, we need to get this audio line, and we need to establish a baseline for this. So what I'd like to do is set up the frequency generator in order to input some kind of audio. I like it a little earlier in the circuit, and we'll just see if we get the right thing on the outputs. So if I put 100 millivolts into where the microphone is, how much gain am I going to get on this through the amplifiers? So we've got a 5-volt offset on this thing already. So what is the procedure here? I mean, if I put a 0 volt on this, it's not going to be able to output it properly because it's when we're dealing with AC and DC lines, I don't have differential I don't have a positive and negative rail on this thing right now. So what we're doing is, and by what we mean by virtual earth, is we're offsetting everything. So that AC signal needs to be moved up in order to get the full wave inside of here. So while we're looking at this thing on the oscilloscope as an AC wave, you have to know that this signal exists as that AC wave, but it's been offset in DC. That's how we do that. You give it a couple volts headroom, and then it'll go a couple volts over that and a couple volts under that in order to create the wave. And that's what we're dealing with over here. So over here, we have an offset of 6.5 volts or something like that. What exists after this capacitor that's blocking the DC component. So I guess if I inject based on ground ahead of this, now nothing is plugged into this line, so I'm going to keep that there. So what I'll do is I'll do negative to negative over here. We'll do it over here so it's local. Local grounds, people. Picks up less interference. And then I'll inject my audio right there. Dear God in heaven, what have I done? Well, that doesn't look quite right. Well, it's a good thing you guys aren't hearing it. So the frequency that we're looking for is 1008 hertz. Now, this is a loud audio signal. This is above and beyond what I was able to put through the amplifier, but it does look right. It just looks like there's a high frequency noise on it, and that's the lighting doing that. Loop your grounds. You know, we had ground loop problems with Burn the Subs. It's kind of crazy that I did have ground loop problems. But what happens is if I don't activate a certain jumper on it and I try to get it to move via the computer, everything goes absolutely psycho. What was I looking for? I was looking to reference the frequency that we wanted. The frequency that we want to pipe through our next piece of the circuit. Now, the other piece of the circuit expects a gain of 6, which I don't think we have a gain of 6 on this thing. We are looking at this part of the circuit, and we are looking to do 1028 hertz. So let's put that in there. Unfortunately, I can't make the amplitude less, but yeah, so frequency 1028, and then we want hertz. 1028 hertz. Now it's, man, that's really causing some weirdness, isn't it? With the scope not being able to figure out what the hell's going on. Center the horizontal there. And then if I actually do the trigger properly, there we go. You gotta get your triggers right. There's a lot of noise on the line. It goes away if I turn off my lights. No, it doesn't. No, it doesn't. No, it doesn't. The final thing does not need it. No, that's weird. Where's all the noise coming from? Okay, so let's see. Amplitude. Can I go below 0.1? I can go to 0 volts, thanks. I can do millivolts. So 100 millivolt. That doesn't appear to do anything. Oh, no. Escape. Amplitude. And then 50. I'd love to do millivolts, but it only, yeah, it jumps to volts. So 0.1 is as little as I can get it without external filtering. So auto is not a good function to use. Do not get addicted to auto tune. If I am to quote Immortum Joe. So this is common mode noise, and it gets filtered out by the differential. I don't know where it's coming from particularly right now. Typically what I'll be able to do is turn off my lights, and then it goes away. I can set a trigger on AC, but we'll just give it a more definitive trigger here. What if I turn off this light? And then the desk lights? Yeah, it's weird. We're getting a lot of noise. Strange. Yeah, it's only with 1028. And I can't do more than a 5-volt offset. So Octojay finally figured out how to use the prime button. 51 months, dude. And your streak is preserved. Hell yeah, dude. 51 month screech. 51 months. Thank you, man. Hey, that's super awesome of you, dude. Let's make sure all the DC components are deleted. Maybe this is, so this noise might be filtered out by the transistors at the end. The prime button finally showed up. Hell yeah. This might be a little bit of the DC component that the transistors are getting rid of, because there's some electronics that exist on the other side of this that might be moved. No, you still got the first. Yeah, you got all your badges. Look at all those badgers. Octojay has been around since 51 months ago, plus like three or 4 months. Maybe 5 or 6 months. Yeah, when the Prime sub ends, sometimes it takes a little while for Twitch to get their shit together, because this whole website you can look at the code for, it's been leaked. So we know how terribly it's coded. At least some people do. I'm interested in the API coding though. I want to see that, because then we get a comprehensive list of all the API commands. Yeah, it's accidentally what is it? Non-consenting open source. I wonder if they've gotten suggestions on how to improve things, or if everybody's been too lazy to do anything about it. So this is an extreme amount of gain compared to what we were seeing before. In my audio levels, we were much lower gain than this, and I can't really do anything with it. What I could do, and again, one thing that I was able to do was actually take... here, let me move these around a little bit. If I inject this at a later, more appropriate stage, then everything looks a little bit better. That's not the right place. Or not. I guess it didn't. I guess that doesn't work. I thought I put it in there and it was able to properly deal with the frequencies that were coming out of it, but I guess not. Okay, never mind. Never mind. Never mind. Yeah, if I put it there, it kind of just breaks things. So yeah, we got to put it. We'll inject it where the mic goes. Now I guess I could do a voltage divider on the 100 millivolts. Maybe we should do that. Do a voltage divider with ground. Let me get two 100Ks and see if I can make a little... I can just do up a quick little voltage divider and we can take that down to 50 millivolts. I think that's the best way for us to do it. We'll do two 10Ks. Is that too much current? We'll do two 10Ks. Because they're right here. Yeah, we'll make a little voltage divider and we'll bump this down to 50 millivolts and then the gain will be proper. Yeah, the DC bump. Oop. I'm not sure about doing a 50 ohm to ground. We're gonna have a 10K to ground. Pickle liquor. Subbed with a tier 1 for 12 months. You're back. Which blacklisted login names are hard-coded? It's not in a database or a flat file. I like the moderator tips, the instaban list. The if they do one thing, instaban them list. That was hard-coded into the website. Ridiculous. We're trying to... Oh, yeah, maybe you have to... Maybe the first stage is doing something. I don't know. Let's just continue forward with what we're doing, though. So I'll do a... No. Okay. The problem with these tweezers is that they eject resistors out of the front. We'll do a 10K to ground. Do it over here. 10K to ground. And then I'll do another 10K that'll go to our input signal. And then I'll run a jumper over to that. If I can fit both of these in one area. Oh god, this is really sloppy. Sloppy breadboarding. It's disgusting. All right, so let's take our positive signal here and we put that at the top of our voltage divider. And then we take our voltage divider and I jump over to this part of the circuit over here. I need a jumper. I need a yumper. Actually, I don't need a jumper. What am I doing? What am I doing? I can do it like this. Hold on. Let's take the signal out of there. Get him out of there. Take the signal out. I'll do the 1 to ground. Fuck. I keep ejecting the resistors. .555s are stupid. All right, so we'll go here with 110K. So let's go straight to ground. Oops, wait, that part, that socket is used up. Hold on, I gotta. There's so many little like connections everywhere. Okay, move that over to there. This will go right here. And I have a camera like blocking me. What does that do for our output? It just jumps around a little bit with the new bias. Hopefully my resistor isn't going to heat up and explode. Yeah, I didn't explain it before because I've been explaining it a lot lately. What's happening is, and it's not happening like physically right now, I'm gonna have to go back through the couple months of streaming and edit or pick out, I'll probably go through Streamlabs, or the Twitch has like a list of events that happen that you can kind of like filter through. Since the subscription of the person that broke the board, I'm going to take all the names of the people who have subbed and put those on one list, and then all the people who have been gifted subs and put those on another list, and then I'm going to use those as the initial injection of names into the new board. The new board is going to have minimal font sizing for both subs and gift subs, and they will be the same size throughout. So the first person to go on the board is going to be randomized. It's going to be randomized. That way there isn't like a fight for who goes in first. I think that's a little bit more fair to everybody. All right, this is a little bit closer to what my input signal looks like. So we just did a simple voltage divider because analog electronics. Now the DC component that we are seeing in here, I don't really know what to do with that. I don't really know exactly what to do with that. That little like glitch that we're seeing in there isn't present when we actually put audio channels in there. Oh my God. Dear trigger, where are you? I think we need to change the trigger type. Yeah, because it's looking for like a DC edge. What can we do on this? Timeout duration, slope, pulse, no. Video pattern, no. Timeout, no. Runt, no. Window, delay, STP hold, nth. No, all these are too advanced. This is edge. Do an upward edge, and then I got to move it to the right position. All this noise will mess with your triggers, so. Okay, so there is our audio signal, and right now, that is 1028 kilohertz, or at least near enough as makes no difference to my frequency generator. If I turn off the desk lights, our signals clear up just a tiny bit, and our trigger is a little bit more accurate, but we'll just take it or leave it the way it is right now. So this is what's coming out of, so this is the, we're powering the microphone amplifier, the mic pack as I call it, the microphone amplifier. We're powering with phantom power. We're not outputting audio channels to it. We are injecting a virtual electret microphone signal in the tune of one specific frequency. That one specific frequency we will put through this audio filter right here, the one right in the middle, in order to figure out whether or not we can get this thing working. So now what we'll do is I will break the circuit here, and we will route that through the first stage of the EQ, and we can check over what's going on. Like I said, take it in baby steps. You do little bits, or like I meant to say, I don't know if I actually got to that part of actually talking about what the hell's going on here, but what I meant to say, like I meant to say, you take it in stages, everything in stages. So if you have a problem, and like sometimes I'll go for broke and try to do the big complicated thing first, just to flex, just to like show off that I'm actually good at this stuff, which nobody seems to like give me credit for. Like I'm getting oscilloscope advice on my own fucking channel. I know what I'm doing, and so sometimes I'll try to do everything at once and show you guys how cool electronics can be, like in one 5-hour show, right? Boy, you know that's not that command I could have used the other day, even for my moderator. But so anyway, this stuff right here, there were mistakes. I made little mistakes in both parts of the circuit. I haven't checked over this part actually. I'm just assuming that I made mistakes. Maybe I'm perfect, but over here I made a bunch of mistakes, and I corrected them. There was one part of the differential amplifier that wasn't even getting any signal. There were a couple missed values, like mixed up values of capacitors and stuff over here. And then there was a little bit of a confusion wiring going on down here. So I corrected all that stuff. And now, and as you guys saw earlier, I was able to switch my regular microphone with this and nobody noticed anything wrong. So we're keeping this part in the circuit now. Let's pipe in a little bit of this thing. So what do we got here? Well, what we have is not a BC549, it's actually a 3904. I don't know about the performance of the 3904 versus the 549, but Fatanon literally tried that with his comment. I'm not going to use scripts in order to make the list. I hate to break it to you. I am literally going to look through the list on over here. I'm literally going to look through that and figure out the names. Sometimes it pays to just do the work, right? Follower emotes, beta access unlocked. I don't want to use follower emotes. I don't know about this whole follower emotes thing. Hold on, I'm going to cough. All right. Do you guys know that when Tomato mutes, he's actually eating a scoop full of peanut butter? What if it's 0 indexed? Oh no! Echo hello chat. God damn it. Ah, where's my mouse? Okay. Hey, I indexed my microphone labeling by 0. I had a 0th mic connection. It's random. It's not 1. Anyway, okay. So we got a 3904 in here, and I need to check over the rest of the circuit. Now, the thing that I don't know is where to get positive and negative VE. So positive and negative virtual earth. Why would I need that there? Why would I need that there? What would that do? The positive virtual earth, I know that Elliot uses to power opamps and things like that. So I'm going to take that as my power. So my power, my positive power, I'm going to take as virtual earth. But negative VE, is that in reference to the 7-volt offset of virtual earth, or is that just going to be ground? Because we're talking about a mic pack versus stereo amp. Now, the stereo amp might think ground is something else, but then they've also got earth connected to stuff. So is earth negative and negative VE is a decoupled negative, or is it a decoupled positive, or is it, my brain, or is it going to be something else? I don't know. One way to find out, let's start punching into things. But we don't have the luxury of plus or minus 15 volts, right? So that's not what the circuit that we have is. So we gotta figure out where it goes, and I think we can use it this way. I think we're fine doing it this way. Oof, I guess we need to zoom out on this. How far out can I get on this thing? Pretty far, but I can't focus it because of the optics. That's about as far out as we can get reasonably. Sorry, yeah, it's a little brain injury simulator. That's about as far out as we can get on the microscope. So here's the circuit that we're actually looking at. And you can see that some of the values of components that I only had in surface mount flavor. So I had to actually make surface mount adapters to it. This is not a very complicated circuit, right? And if we look, our 3904, because of the way these frickin' through-hole transistors exist in space, we need to actually get like a 3-dimensional drawing of the transistors. So here's the 3903 and the 3904 datasheet. Pins 1, 2, and 3 are displayed in 3 dimensions now. They didn't used to do this. You used to get a symbol on these frickin' things that was just like, they were just like, here, you figure it out, you idiot. And they're like, they do this, and they go boop, 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 and they go 1, 2, 3. But if you look at the shape of this transistor, it looks the same from the top or the bottom. And sometimes they would be like top. And you're like, wait, I'm looking through the thing to see where those pins are? Or they do like bottom. And you're like, why am I looking up under this thing's skirt? But the better ones are the ones that would just do nothing. And you were left to wonder if you were looking through the transistor or if you're looking at it from below. And this is important because you don't want to hook these things up wrong. So nowadays, they default to giving you a nice little outline view of everything and telling you where the pins are. Yeah, they are evil, indeed. So yeah, anyway, what we're looking at is pin 1, 2, and 3, collector, emitter, and base, right? So the base is in the middle. The collector is on the right side if you're facing the flat point, and the emitter's on the left. So go back over to here. We take a look at what we're looking at. This is hard for me to... Whew, I had to swallow a burp. This is hard for me to like completely display to you guys because I have to have a schematic open on one piece of paper or on one monitor, and then I have to have the diagram, or sorry, the schematic on one monitor, and then I have the pinout on the other, and then I have my microscope view on another. Like it's I have to cover over chat for this, and I apologize. But right now, I just need to do a quick checkup on this circuit to make sure that I got everything right. So what we're gonna have, and if you want to follow along, you need to look up projects 143. Oh, I guess I could do this. Why are the thermals not working? Well, let's get rid of that. Oh, it's just not even in here. Okay. That's that line. That's that line. There we go. Forever farting. Thank you for following. That's got my old giant view of everything. All right, so yeah, here we are. Oh, this is actually a good view to use. That's the Brady Bunch view. All right, so right here is our input. So that would be the filter in, and you can't really see it, but that's all the way over here. Maybe I'll do this. Okay, so filter in, coming in through a 10K ohm resistor. Mr. Worldwide, Mr. Seven Figures, thank you for following. So 100 kilo ohms, or sorry, 10 kilo ohms input. We're gonna get the multimeter out too. I'm gonna pull out all the stops here. Meanwhile, we're just injecting a frequency into the EQ line. So this should allow us to adjust the EQ, but first we gotta make sure that I put all the right stuff in the right places. So let me move this all the way up here to where it's slightly visible. I can move here. There we go. There we go. Jeez. We're pulling out all the stops today, man. When you do analog audio stuff, it really takes up an entire lab. The only thing that's not visible here is chat, and I guess I should probably put you guys over my fucking face. Hold on, let me grab chat from another. And then we'll put multi 4. Let's just get everything up at once. In my other monitor, I've got the diagram for this. So I'll put you guys on screen. Let's keep it to English here, folks. Oh, you got it. Okay. I was just switching. I was like, where the fuck is the window? I got windows all over the place. Yeah, you know, maybe Russians are very interested in analog audio. It's fine. It's just we do English here. That's just how we do. You guys, you're still in the way if I put you over there. I have to like peek around you. Yep. Thank you. I was just working on that. Oh, good. My glucose level's coming back down. No, that was fine. His message said he doesn't really understand English. You try Google Translate, but we want to keep it English around here. I want to keep it English because I don't know how to reply or moderate foreign language messages. I don't know how to moderate them. I can't do it quickly, so we got to keep it English. You know, that's just what we got to do. That's impossible to read. That cuts you guys off. That's moving. I know that's not useful to anybody. That blocks my ability to read the schematic, and that's stupid. So let's just put you guys like this again. So you'll be over my face. Don't speak English well if something... No, it's, I don't listen. He jumps right to politics. All right, so let's test this guy right here and make sure it's a 100K. I can see by the color bands that it probably is, by the way that it is. 9.98K. Oh, that's good because it's actually a 10K. All right, so that's the 10K ohm that comes into there. We have a capacitor right here that I'm not going to test, but that capacitor's value is 0.22 microfarads. So this is the 1028 hertz location of this circuit, and that's what we've got going on here. Right now, this thing is reporting that our frequency is all over the place. Never mind. There's a lot of noise on the line. So yeah, so there's that. Then we've got a resistor to ground, and I'm going to assume that ground, in the case of the microphone, I'm going to assume that our ground is this down here, not the virtual ground. No, I don't have the color bands memorized. The last time that chat was allowed to talk about mnemonics for color codes, it got racist very fast, because fucking electronics used to be a boys club in like back in like the early days, like the 40s and 30s. Yeah, yeah, both. They hit both marks, because it used to be a bunch of fucking idiot asshole nerds getting together and being some kind of a fucking boys club. I hated it. We don't, I mean, most of the mnemonics that exist today are fine. It's not entirely. It's, you know, this stuff is slow, but it is turning around, and it's more accessible to a lot of different people nowadays. And so I don't like to something made like a snapping noise on the desk that sounded like a spark, and it concerned me. It might have just been something tapping against something else, but I thought maybe I shorted something out. So I was kind of being pretty attentive for a second there, just to make sure that nothing was breaking. Anyway, there was like a snap noise on the desk. I thought my 40 volts was snapping at something. So I never learned the color bands. I never thought it was necessary, because even back in my day, like 1,000 years ago when I went to college, the value of the resistor in what's up with the color coding? Okay. The color coding on resistors tells you what the value is. This is how they used to do it back in the 1850s or whatever the fuck, when they were using through-hole electronics. Nowadays, we have surface mount electronics, which have the value printed directly on the thing in lettering, so that you can just read it. It doesn't matter. I hate color-banded resistors and through-hole electronics. I should have made this into a surface mount soldered plug-in module for the perforated prototyping board. That's the cool way to do things, and that's how we did the actual chip itself on the circuit. I kept with the surface mount, and I put it into an adapter. I could have made a little module board that plugs in to the perforated prototyping board, but I wanted to show some of the basics, some of the stuff you guys might encounter when you're messing with electronics. So we did it with through-hole resistors and stuff, and you know, the color codes I never memorized. I just don't care to. Yeah, it's like 10K, 1K, and then like if you're working with a specific value, sometimes you'll memorize that specific values, and then when you have a test on it in college, that's when you'll actually use the color bands. But yeah, sometimes you can, and especially with like when all the resistors used to have gray and violet were like the same color, and it was so pointless. Color bands are stupid. We have the ability to print actual numbers on things now. Anyway, I'm checking over my work here. So we have a 10K coming in there, and that's confirmed to be 10K. We then have what I am assuming is ground. And I'm going to assume that this ground is the same ground that's in the schematic that we have down here, not virtual ground. This exists at 7 point something volts. So it's possible that virtual ground is supposed to be that ground, or at least this circuit's virtual ground is supposed to be that ground. But this pin right here, I am going to assume is ground. It's where all of the logical grounds are connected to anyway. Mic minus being what it technically is. He gave it a different, or no, I gave it a different arrow. So that's what I'm assuming all the grounds go to. They should use Roman numerals, what, like a little barcode on the resistor? Okay, so that's what I'm assuming is ground. It might be a wrong assumption, but we'll do that for now. Minus virtual earth. I don't know what that is. That might be a decoupled ground. That might be a decoupled positive. I don't know what to do with that. Plus and minus 15 volts are what's supposed to be on the 2 virtual earths, in which case I should take ground as virtual earth and then take plus and minus to be the DC, or sorry, plus and minus should be 7.5, no, plus should be 10 volts, ground should be virtual earth, and then minus VE should be 0, DC 0. Maybe that's the way that I'm supposed to hook this up. Yeah, don't listen, guys. Don't perpetuate those fucking things, because they're. You can look up a page of mnemonics for the color codes of resistors, and there are ones that aren't fucking horrible. So don't. And if you repeat them in chat, that's going to be a 1-week ban. So just don't do it. All right. I'm not going to accept that, because the last time we talked about this, I had people share those mnemonics and go, "What? That's how you do it. I didn't do anything wrong." No, you're gone for a week if you share anything like that. Okay, so anyway, because like we don't like, who the fuck? This is the same thing with my friend. I'm sorry to rant, but I need to rant about this. This is like my friend who worked at a gun store, right? We're talking about gatekeeping. We're talking about gatekeeping right now. That suddenly shifted the topic over to that. Don't know how that happened. We're in a niche. We're a niche of a niche of a niche. We're the niche of the niche. We are in a niche. Ni hao. We're in a niche here, right? And this can tend to be a little bit of a boys' club just because of the people who are interested in this kind of thing. It shouldn't be that way. I am a big fan of, hey, gates are open, everybody come on in. Artists, engineers, people who just like to fuck around with things that spark every now and then. I think everybody should be allowed in here. And when you put in a mnemonic that's horribly sexist, it's not comedy anymore. It becomes a little bit of a gatekeepy thing, because everybody's going, and it's like, it's stupid. So electrical engineers are not the funniest people in the world. I know I have a lot of people who like to watch me do stuff, and I'll say it first, we don't have a great sense of humor. And so when it gets into subjects like that, like, it's just not acceptable. It's not acceptable, because we need to be more welcoming. And why'd you mention your friend at the gun store? My friend at the gun store, he is completely deaf to the difference between a clip in a magazine. He doesn't give a shit what you call it. I think he'll always call it a magazine, but he will never scold a single person about calling it a clip, because guns are a niche, sort of. They're a bit of a boys' club most of the time. The hobby of guns. And they don't need those gates. They don't need those gates to be put up. And they don't need people keeping those gates. So the same thing with electronics. So when the people that don't, and mainly I'm ranting for the people who in the past have complained about having their, being punished for sharing these awful mnemonics that exist for remembering all of the different bands of the resistors, which in and of itself is obsolete. As far as I'm concerned, you don't need to know the bands of the resistors, and if you want to, you can look it up, and that'll help confuse you, and maybe you can send a cool code-worded number to your idiot friends. But as far as I'm concerned, memorizing the bands on the resistors is totally fucking useless. That's just me. And in doing so, when I mention them, we get people sharing the awful mnemonics. I just want to not talk about that here. We don't need gates to be in the way. All right, anyway, that was my rant. I just want to also mention it because of the difference between clip and magazine. Doesn't matter. You don't need another thing that you're going to lord over people that you know how to say that they don't. It just makes people like not interested. And so when you share horrible mnemonics, you might think you're being funny, but you're actually discouraging people to participate in our niche, our niche, our niche. Anyway, back to the view that I haven't used in like 6 years, so that we can actually see this stuff. So anyway, I'm looking at the resistors here and I'm tracing out my schematic. And I think the way that I just described the horrible burp that I'm experiencing. Okay, anyway. I think what we need to do is take these in terms of what their potentials are and where they exist in the circuit, because we've taken a DC circuit and we're treating it as an AC circuit. And what I think is that up here, our plus VE, which is going through, no, sorry, our filter input is going to be our audio signal. I think the next one down might be our plus VE. We'll have to figure that out. Or we might have to take this out of it. Yeah. Oh no, our plus VE is still our positive 10 volts. Our ground, which we'll have to pull out of the circuit, these two right here, we'll have to pull these out of the circuit because I think our ground is supposed to be our offset, our 7.5 volt offset. And then our filter, or sorry, our negative earth is 0. And then we've got the filter output. Oh my God. All right, so this negative we have to pull out of the circuit. And actually, I could do this a different way. It's going to be a little confusing. Is that I will take the negative down here and I'll isolate it. So now that entire band going all the way down the perforated, going down the breadboard. Why can't I get, man, talk about brain plasticity earlier. I can't unlearn the terminology that I'm using wrong. So let's get negative off of the rest of the circuit. So now that's isolated from the rest of the perforated the breadboard. Fuck. And then this is 10 volt. Yeah, I think so too, Pyro. I think that was the sussing that out. Amoga, sus. I think sussing that out was the important bit about this. I don't know what that is. I don't know what that is. So yeah, no, our ground is now just on this band. Our positive is at positive 10 volts. Let's check over the rest of the circuit and just make sure that everything's right before we proceed. This is the part of the project, or maybe you're working on something like this in a college lab, and you're trying to figure out why your circuit doesn't work. These are the kind of what? Oh, you mean Haribo Gold Bears, the sugar-free ones that? Haribo Gold Bears are actually my friend's favorite candy. That and flat Pepsi. I don't know what's wrong with him. Something's broken in his brain. This thing is actually more potent than Haribo Gold Bears. This stuff that I've made. Ishkar, thank you for following. All right, so here's the deal. What we're doing right now is directly applicable to working on actual circuits in the real world. If you're going to go through an electrical engineering education, or you're just going to try to do a project for yourself, you're going to run into a part where everything goes wrong and you feel like tearing your hair out, and or just tearing all the plugs out of the walls in your home, and then living curled up in the darkness for the rest of your days. Do not fret. Everyone has been there. I was there last week when we completed this circuit. The solution to that is, of course, hunkering down and doubling up on your efforts. I am of an opinion, and this is my own personal opinion about the thing, that smartness, people's evaluation of what smart people are, is completely off. Smart people are just more adamant in attaining the end goal. And so you need a little bit of adamance on this thing. And if you're tired of the circuit, take a break, come back to it. That's what I did. I took a break, I fucked off, I did a bunch of other stuff, and then I came back to the circuit. If you're in a job environment, you need to go and do other tasks. If you're in a home environment, you can go cry and then come back to your circuit with a fresh mind without being bogged down by all the stuff that you might be tired of or confused with. So what we're doing here is we're going over the circuit tiny piece by tiny piece in order to figure out where the mistakes are and whether or not, things need to change. And a little bit of that attitude is what brought us to the conclusion that maybe our grounds and our earths are in the wrong places. So that's what we're working on right now. So, all right, back to the super view. So we are, we're here. Hold on. We're here. We evaluated this much of the circuit. Congratulations. It's good to be here. Let's just check. We checked that 100K, right? We'll check it again. I'm going to concentrate for a minute here, by the way, guys. 100K. All right, cool. We got a capacitor in there. I can't measure it, but these two are the same value. They should be within tolerances. And of course, the accuracy of the two capacitors is going to probably vary statistically. It doesn't really matter, but if we really wanted to get high precision components in here, then we would probably get exactly 1028 as we're supposed to, according to the equations, but that's fine. So, all right. So our connections are as such. We've got those. Our positive power in coming from over here is going to this outer pin right here. What is this pin? What is that pin? So that pin, we're looking for the collector. The collector's pin 3. We're oriented in the right direction. That is the collector. All right. The other side of the capacitor connected to the base. Yes. And then it's got a 100K that goes to ground. Double yes. 100K to ground on the other side of the capacitor. That side also has a 560 ohm resistor. Or does it? Hold on. Let's look. I gotta cover you guys over again. Sorry. Which one is the 560? Because we've got this one here. We've got a 560 ohm resistor to the emitter. Okay, so that's the yellow wire. So the yellow wire is bringing that signal all the way down. So this signal right here is the other side of this capacitor. That's wrong. Wait a minute. That capacitor goes to ground. This goes to ground. This is in the wrong place. That goes to the base. Hold on. Let's think about this. 560 ohm. This one, that's to ground. That's wrong. That is wrong. That goes to not the same. This is wrong too. Wait a minute. Hold on a minute. All right, yeah, something's totally fucky with this circuit. Multiple screw-ups at once. So the collector here is connected to positive power, and that's it. Good. 100 kilo ohm resistor to ground. That's connected to the other side of this capacitor. This side of this capacitor. So we're supposed to actually be coming from here to the 560 ohm. And then we've also got on the other side of the 560, we have, oh dear God, what have I done? Yeah, there's a couple different errors with this right now, I think. Our other capacitor goes to ground. So that goes to ground like that. So actually, it would be clearer if I moved this over here. Yeah, let me reverse the order of these so that it's a little bit more clear what the circuit looks like. These circuits, by the way, when I built them, I just visually made them the same. So let's move these around, and that'll help me visualize it a little better. And then move that over here. This one's taking our input. Ah, damn it. Taking our input there, going in through there, through the 10K, through the 0.022, although the circuit in front of us is a different value. And then I had, I can't do that. Wait a minute. Hold on. I've run out of space to actually put the other capacitor on here. But that one should just go to ground. These can't make the jump to ground, so I do it this way. Oh God, what have I done? What have I done? Screwed it up. Hold on, let me clean that up. Clean that up, clean it up, clean it up, clean it up. What I'd like to do by the end of the day today is to be able to show you guys the circuit in situ actually filtering the frequency that we've given it, right? Because that's supposedly what should be happening here. And if we can't do that, then we can't do that. But this is a relatively simple thing. And then we can show that this EQ does work, And I can then set up in order to do the audio testing on my own in order to get these tuned properly. So yeah, that's a little sloppy, but I'm gonna have to live with that. I'm gonna have to live with that till the end of days. It's a little sloppy. So we got our negative, quote unquote, our earth negative or whatever, and then our positive there. And then something else weird is going on around here. So I'm gonna start ripping stuff up a little bit here, just to get a handle on what I'm actually supposed to be doing here. So yeah, let's just eviscerate the entire circuit and let's just build it over again. Make sure that I get it right. I'm sure there was just one correction on this thing, but I'm confusing myself and everything's wrong. So okay, we've got ground here and we've got our first capacitor, C1.6. C2.6 goes from this capacitor to ground. So we can actually just put that, I'll just put it over here. Well, should I do it over here? I'll just do it right here. Actually, no, we don't have any other connection there. Oh, but we're going to have to be able to reach all the way up to this. So I'll do that here. So there's our second capacitor to ground. And these are actually what tunes the filter to the frequency. So C1.6 and C2.6. All right. C2.6 only connects to ground. So this is the only connection on this band right here. Up here, we have a 100 kilo ohm to ground. And then we should also have the base of the transistor. So we need to go from here to here. Is that correct? Yeah. It's all the way up here that we actually have several different things connecting all the way up here. So this to the, man, there's a lot of stuff here that needs to connect to one another. There's a lot of different things. Yeah, clean up. Clean up on aisle 21. I can actually read chat because it's big on the screen. That helps. I'm big on that screen. I'd actually rather this be over here. And then I can move. Wait a sec. So the 100K to ground is on. Yeah. Wait, but the. Oh, yeah, C2.6, right. I keep confusing 1.6 and 2.6. That's what's getting me in trouble. So the base is connected to the 10K of the input. So I'll do that like this. We'll have to use the other row too to get this stuff. This is getting a little confusing and I'm sorry, but this is what we're in for. So there's that connection right there. And that connection is that I just connected is, where's my cursor? That would be this. Right here. That's that connection. Well, it's also, wait a minute, no, it's that connection. Oh God, oh dear God. I connected it all wrong. I did everything, everything's wrong. Everything's wrong. Where does that fall? No, that is, no, it goes to the 100K to ground. It's actually supposed to be on the row below it. My bad, row below it, row below it. Can I use this jumper to do that? This is why we check over our work, man. I'm all over the place with this fucking thing. So we're supposed to be on the same one as the 100K to ground. Yeah, I need a smaller jumper. Yeah, I'm screwing it up. This is what I'm talking about. You lose your concentration or get a little distracted. Were you looking at the girl in the red dress? Oh God, I just talked about not being misogynistic. All right, let's get a smaller jumper out of this whole ordeal. Let's see. This is like a much smaller jumper. I don't think this is gonna do it. We're trying to go from the 100K to the base, and yeah, I need like 2 more holes out of this thing. My jumper kit has been through better days. I think it's on its last legs. Oh, no, you bastard. It's so close. I think if I straighten this one up, it'll work. There's like weird sizes in this jumper kit that just don't quite get there. Okay, so this... Ah! No, I lost it forever. There it is. I got it. I got it. I got it. I found it. I got it. I got it. This is what I'm talking about with like building a module. You don't have to deal with all this stuff. You can just hook modules up to modules. I like working that way better. Okay, so there's the 100K to ground. There is the base of the transistor. We have the C1.6 going into that. We have C2.6 going to ground. And then we have the 10K ohm resistor to the filter input. Now, we need this or this to go to a 560 ohm resistor that goes to another mess of components. So let's do the 560 ohm resistor, but we'll put that, since it's not a through-hole resistor, we need to put it like down here. I'll just place it down here. Actually, the 560 ohm resistor goes to the emitter of the transistor. So it goes between the capacitor on the base. So it doesn't go exactly to the base. So we can put that right here. Would this be a good FPGA project? Yeah, I think so. But the thing is, like, you got to get into weird filters with FPGAs. But yeah, I mean, you could turn this into digital and then back. You just need to power your FPGA off of 10 volts. So that's something for another day. I'm not going to jump into FPGAs for this and make my microphone packs digital. We're going to keep it in analog audio because it's done me very well. Krawoozy, thank you for following. Okay, back to here. Back to here. Back to, yeah, what I'm doing. Okay, so the emitter goes to a 560 ohm resistor that now needs to go back to the front of the capacitor. So after the 10K, we need to go back here. Oh God, how are we gonna do that? I've run out of spaces on this. This needs to go here. I could go around the back. I guess that's how I'm gonna have to do it. Let's go around the back. There's nowhere else for me to really pick up on this, unless I move the resistor over or something weird like that. Yeah. Just learned about FPGA. I think you just make circuits and code. Not really. FPGAs are logic gates, and logic gates are a little bit different from what we're doing right now. FPGAs can go over a lot of digital information at once because they are the base sort of thinking component in electrical circuits. But when we're dealing with logic, I mean, you can do TTL logic, which is something from yesteryear, or you can do lower voltage logic like in FPGAs, where everything is in parallel and it sort of exists in a weird universe of strangeness. FPGAs are confusing. They are extremely powerful. They're tough to deal with. And if you learn them first, you'll be very confused about things. But what we would do if we did this with FPGAs, what we would do is we would turn this analog audio signal into a digital stream, a serial signal that could then be worked on by digital components of the logic gates and then spat out in record time. You don't need that, though, in order to mess with I2S audio, which is a digital audio standard. You can actually use a teensy 3 whatever to manipulate audio in that manner. And then we could put all the filter blocks in there without having to go into the nitty-gritty of all the different coding and stuff. But FPGAs are a bunch of logic gates, and so they can work on stuff in parallel very quickly. They're wonderful for that. But we're dealing with analog audio, so we're going to keep it analog until the end. Is there an analog equivalent of an FPGA? Man, I don't know. I don't know, dude. I mean, everything is analog when you boil it down far enough. I need to go from here to here. How do I do that? From all the way down here, all the way up to here? Or no, I need to go here? No, I need to be on this side of the capacitor. Because this side of the capacitor should be shared with, then what's this doing? This is in the wrong place. Because the 100 ohm to ground should be exclusively, aha, mistake number 4, section 7. Nope, this is another mistake. So I'll put this up like this. Because we go 10K input, capacitor, capacitor. One of them leads to the rest of the circuit, and the other one leads... Okay, there's another one. See all these little mistakes that I'm making along the way? That's what we got. We got to correct them. Correct them. Never heard of them. So this one will be better if I do this. Come here. Come here. Let's go right there. And then grab another jumper. One that I haven't twisted. I guess maybe that's this one here. And then we can go ground to this capacitor. Fuck! It just flew off of the tweezers. I don't know where it went. Found it. I found it. All right, so that goes here, the ground, and it's now significantly less confusing. So 100 kilo ohm, or sorry, 10K, this is R1.6 into, I think these resistors do the Q, but R1.6 into a capacitor that goes into the base, and also has a 100K to ground. Also into a capacitor, C2.6, that also goes into, not positive, that goes into ground. Damn it. Hold on. I got to move this over one. Move that over one. Grab this. Our other circuit is still live. Move this over to there. Okay. A little bit more organized on this, right? Okay. So there. So that's the entire beginning part of the circuit. We then have a 560 ohm resistor, what comes from this junction right here. So to get that, I guess I could just jumper over this thing. I'm gonna get a larger jumper and just go out and around. I hate going out and around on these circuits, but I'm in a situation where I won't be able to. Rocket pants, pocket rockets. Thank you for following. So we go from here to the one end of the 560 ohm resistor that is not connected to, yeah, okay. So that goes here and then here. This is not that part of the resistor. It's the other part of the resistor that we're talking about. So the other end of the resistor then goes to this 4.7K ohm resistor. That's this right here. You can tell it's 4.7K. It's got a weird yellow color band on it, right? I think 7 or 4. I think the 4 is yellow. Okay. Right. Cool. So far, so good, right? So far, so good. Or at least that's what we keep telling ourselves. That goes to the emitter. Yep. Okay, so now we have a 10 microfarad capacitor that we need to put in the right orientation, blocking some kind of a DC component. So there's the negative band of the capacitor. That one's going to face our 560 ohm resistor, and it's going to hit the same pin as the emitter of the transistor. So let's put that in here like this. So we're now going from this pin right here, skipping over one, and coming down here. Now, this isn't the best display of how the circuit is oriented. You know, it's a little bit convoluted, but is what it is. I could probably spread this out in a slightly different manner and make it a little bit more clear what's going on. But right now, we're at least making progress. So from there, we're going to go through our potentiometer. So we've got one of the ends of it is connected to the capacitor. So I'll come over here with that, plug that in like that, and then finally, it doesn't quite fit. Okay. That doesn't quite fit. It's kind of annoying. I could probably put that on a jumper if I'm really... Yeah, let's put that on a jumper. Put that on a jumper. That'll move everything down a little bit. it'll be a little bit less less compact, and we can probe around it if we need to, right? So if I take that and I jump it down to here, remember we're only working on one of these. I'll have to do the edit to all the others. So we move that down there. So yeah, that one skips that row and then comes down to here. And then we have our output resistor. This would be the 22K. I'm gonna try not to have this fly out of the tweezers, even though I am gripping it pretty hard. There we go. And then between the two, we put our potentiometer. So you can see there that there were many mistakes that I've made. I've made many, many mistakes. But now that we've corrected them, we've got areas that we can test this board. And let me just take this with me just to ignore, so we don't get confused. So we have our input at the top. For input, we have our positive power. We have our virtual earth, which will be our 0. And then we have our earth, and we have our filter out. So to the other filtration circuit we go. And if you'll notice, the way that I've set this up is that I got this wonderful little guy right here. This little thing right here. Cadence 0, thank you for following. I got this little jumper right here, which has no business in a circuit of mine. These types of wire jumpers I relegate to bringing signals in and out of my circuits, and that way we can organize things pretty well. But what we do now is we can break that line, and that line is this line right here. That's how I've set that up. It's this line right here where we can break the connection between the inverting filter and the output amplifier of the entire circuit. That 33 kilo ohm resistor, I'm going to assume, is more of a necessity because we got this 33 kilo ohm resistor right here. And I know it's going into the 33 kilo ohms going into the opposite part of the filter, right? And that's to invert it. So taking sort of the forest for the trees instead of getting blocked by the minutia, I have made that determination. All right, so let's get this thing hooked up properly, which is going to require a bunch of big jumper wires. Jumper, 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 jumper. Jompy, jompy, jump. Dun, da, 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 da. So first of all, Earth. Now we've already got, welcome to Earth. So first of all, we've already got power running. Hey, Billy Bale. We've already got 10 volts running to our positive rail. Our Earth is now changing. It's no longer 0. In fact, our Earth is now our virtual Earth, which I happen to know is this portion of the circuit right here. Now, this is a kind of too much of a jumper. These are all too much of a jumper. Can I get over there with an orange? Nope. Maybe I can get over there with an actual perforated jumper. God, it is so October out. I'm loving it. It's cold and rainy. All the leaves are about to friggin' change. Beautiful. Okay, negative over here. Virtual negative that I don't have any open spaces on. You bastard. All right, hold on. I gotta jump my negative over to another portion of the circuit. I'll just do a jumper to a jumper. I want to keep these open because I'll want to build that amplifier version of the circuit. But for now, we're going to try it with just transistors, which is technically what Elliot likes it. So we should like it too. But yeah, this has got to kind of like jump over a bunch of stuff that I don't want it to. That's way too far over. Yeah, let's just use a yellow jumper. It's way too direct, but we'll just do it. Hello? There we go. I hate it when you press in on the jumper and it just doesn't do anything. It's like, what do you think I am? Some kind of an asshole? And then it just doesn't, like, the jumper just doesn't go in. All right, so there's virtual Earth hooked up to our circuit. It's already having a disastrous effect. What's going on there? Oh, it stabilized. Yikes. Yikes. All right, so the next hookup is just for this circuit, and that would be our filter in. That's going to cut off our output, and this is our filter in. Then the 4.7 kilo ohm output is... Wait a minute. Is the 4.7 kilo ohm output to virtual earth? Hold on. I think I got it wrong. Hold on. Herp. 4.7 goes to negative, which is negative 15 volts in the circuit. In our case, that would be 0. So that's what's going to ground. Oh yeah, it's November. It's November. It's November. It's almost my birthday. Tomorrow I become even more into the comedic basement dwelling age. So this has to go over to minus over here. So we need a smaller... I don't think I have anything in between those sizes. I don't. Yeah, red is longer and yellow's even longer. There's no in between sizes in this kit. Negative VE, so we're thinking about audio as like rail to rail, and when we do that, we exist in an AC system. So we need to make a virtual earth which exists somewhere in between positive 10 volts and negative, or sorry, and 0, right? Because we're in a DC system. We have direct current coming in through the microphone on the phantom line, which is 10 volts. So we have positive 10 volts and we have 0. Well, we don't have anything in the negatives because we don't have a negative supply running to the opamps. They can't operate like that. Plus, we're not actually even working like that. So what we need is a virtual earth, what exists somewhere in between. And Elliot, in his infinite wisdom, made that 7.5 volts for some reason. So we're going to make that 7.5 volts our virtual earth. The microphone works in AC too, and we've given that a little bit of an offset. We've injected an offset into it, but then we get rid of the DC component of it. So I don't know exactly how that's happening. I guess the electret microphone needs power to work on, and it works in AC, and we delete the AC, and then we put it in, and we do the virtual. I don't know, man. Is something going to explode on here? Is anything like hot? I don't think so. I guess I could check. Now we're good. Okay. I think the heat's on, and I'm just smelling the heat. Okay, so we need to move the 4.7 kilo ohm resistor to earth. I have to use an orange jumper because it's just that long of a signal that needs to get there. So this one comes over to here, and that goes to ground, virtual ground. The name is ground, virtual ground. All right, and then our last hookup is our audio out from the filter. These jumpers are too long. I need a shorter jumper. My jumpers! Where is a shorter jumper? Well, he's blue. Audio out, back into our differential amplifier, etc. And so this is our 1.8 kilohertz signal coming out of our graphic equalizer single stage. Presumably, I could take a screwdriver, probably better yet, a plastic screwdriver. I don't know if I have one. I had little adjusting screwdrivers sitting in this drawer. I think they're in here. I just can't pick them out because I need to move the scope to get to them. The plastic screwdriver keeps you from injecting interference. But we are seeing a wave coming out of the other side of this thing, which is nice. And if I'm correct, it'll be the opposing wave, right? Because we're looking at the original wave that we're injecting into our EQ and what's coming out of it. Let's try this. It does nothing. It does absolutely fucking nothing. All right, other direction. Nothing is happening, chat. Why isn't anything happening? Why am I not adjusting? Other direction. Nothing. I mean, it looks like the gain is probably proper for us to be adjusting stuff. That's fine. Where's our probe connected? Hold on. Let's make sure our probes are connected in the right spot. So our yellow probe is connected where we're injecting audio. Our blue probe is connected, yeah, on the output after the amplifier. Yeah, when I touch stuff, everything's going to go haywire, just because that's what we're up against here. I mean, it means that our circuit is at least doing something. It might just be tuned for a different frequency, maybe. You know, maybe at this frequency, it's not really doing anything. But like when I start screwing around with it, this should be adjusting it. Actually, it might be. Hold on. Yeah, I see some slight amplification going on in this, but not much. Maybe it needs more than a 10K ohm resistor. Let's take a look at it. If I inject, well, I mean, this would pump it up a little bit. About the same before the resistor. The resistor doesn't appear to be doing anything. I mean, I can barely see. There's like a very... Ow, I just poked myself. There's a very small adjustment that's happening here. It does kind of look like we're in specs. Let's turn this off of AC mode and see what's happening here. So we're at 50 millivolt peak to peak. That's 100 millivolts peak to peak. But it is currently in AC mode. So what I'll do is I'll move this all the way down here, and I'll turn it to 2 volts peak to peak. So, sorry, not 2 to peak. I mean, it's 2 volts per div. So this is 2 volts per div. And if I turn channel 2 to DC coupling, so 1, 2, 3, 4, it's not quite at our virtual Earth. Not quite at our virtual Earth, which I think is okay. But if it's being compared to that, I mean, we're still getting an appropriate output, right? Or no, this is the output from our thing. Is that before or after? That's after the decoupling. This would be before. Ooh, 1, 2, 3, 4, 5, 6, 7. All right, so yeah, well, that's the output from the filter. Output from is the same thing that's actually on the output from the filter. Looks like, yeah, 1, 2, 3, 4, 5, 6, 7. Okay, yeah. So we're at the right potential. We're actually at the right DC offset from everything else, I think. Oh no, I just plugged into the wrong side. Other side, same thing? Yeah, same thing. So I mean, it is functioning. It's actually functioning. Where are we plugging this into? I'm looking at this. There we go. So if I put this back to AC coupling, and I go back down to the millivolt range, 5, 2, 1, 500, 200, 100 millivolts. You can see it in comparison to its buddy, the other output. But we're looking for a similar amplitude. So, This is what's going out to the filter. This is what's coming from the amplified version. This is a full input to output of the filter. All it's doing is lowering it. And it doesn't appear to be as adjustable as I would like it to be. Unless these things are like 10,000 turn potentiometers, which I do not think they are. So what is happening here? That looks about to be the same amplitude. I mean, is it going through? Do I have the pinout wrong on the pot? Nah, that's what it is. Yeah. Do it from the other end. I mean, maybe the 22 kilo ohm resistor is a little bit too much. It's going to need a little bit of work, isn't it? Now let's zoom in on 2 and see if there's actually something going on. I go way the hell in, and I'll turn off the lights so that we don't see all that noise. And if I adjust this one direction, I feel like it is changing very slightly, but not as demonstrably as I would like it to, huh? Go the other direction. It's doing nothing. It's not doing anything. It's useless. I actually did reverse the direction of the potentiometer, but it's literally just a wiper across a resistive material, so there's not really much going on. the center pin is always going to be the center pin, and the end pin is going to be the end pin. The value of the potentiometer, though, 10K, that's what I have sitting here. The other potentiometers that I have are like 100K. It's just strange that this is not editing this frequency at all. Maybe it edits a different frequency, though. Let's go to 2 kilohertz. But I mean, if it is transmitting back this at a decent clip, I don't know, maybe it just doesn't. So yeah, there it is at 100 millivolts. You can see what it's like there. So let's put in a different frequency. Let's put in 2 kilohertz. That didn't do anything. 2000 hertz. 2 kilohertz. Nada. It just seems to be dirtying it up, huh? Let's go 500 hertz. I mean, actually, we could just sweep the frequency across this thing and see how it responds. Let's do that. So let's see. Mode. No, that's not what I wanted. Which one do I adjust here? For F or T, that's not what I want. I want... Oops, I need to put it back in. Let's go 2000 hertz. Waveform. Square. Not really going to do it. Triangle. Ramp. Ramp. User. I think we need to change the mode into sweep. Yeah, sweep. How do I select that? Sweep. So for our waveform, we want a sine wave. This thing is kind of hard to use. And then start at 500 hertz. So do I get to adjust the amplitude and offset? Amplitude, 0.1. Okay, it kept those. Start is 500 hertz. Stop is, I don't know, 5,000 hertz? Fine, 5,500, fine, whatever. So do we get our sweep out of that? Oh yeah, there he goes. Look at that sweep. The potentiometer is just a volume knob, but this thing will be sensitive to certain frequencies, so we should be seeing a variable amount of output depending on what frequencies it's hitting, and we're not. Yeah, it's a specific frequency band's volume. Yes, exactly. So is it adjusting at all? Go the opposite direction for a couple turns. It is not altering it at all. Hold on, let's definitively test this. So I am going to, well, first of all, that cuts it off. That's our output up there. Let's take this to the multimeter and let's put it at 50 kilo ohms. I'll do it like this. I'll plug it into the board and then I can put the probes on it. Plug it into the board, put the probes on it, adjust it to 50. We were at 5. Get a feel for how this thing works. Oh god, this is a lot of turns. Look at that. That's the rate that I was... This thing is 50K. Oh my god. This is like 1 billion turns. Alright, here we go. Oh, damn it. I broke connection. Hold on, you can actually plug these in. There we go. 9K. Oh god, here we go. Here, you guys. Is that a known good potentiometer? Yeah, that's what we're testing right now, huh? Funny how that works. Funny how I'm a step ahead of chat at all times. Shit. Wait, 10K? Oh yeah, it says 10K. All right, never mind. So that's 10K. So let's plug 10K into it and see what happens. So we're supposed to be seeing a sweep of different... Oh, I'm going to focus the camera here a little bit. We're in low light right now so that we can eliminate noise. It's supposed to be getting... The signal's supposed to be getting larger and smaller, and I can somewhat observe that. Let me put the cursors on here. Actually, wait, if it's 10K, I'm going to flip the pot around, and then now this will be at its lowest. So it should be as loud as it gets. That's what we want. And so cursor, we're going to do those. I'll do one on the top. This is just for reference. In a real frequency generator, you would have control over the speed of the sweep, but I don't think we do here. So what I'm looking for is for that to get significantly louder at a certain frequency, and I'm not seeing it. Now, are the values of my components off? That's always a possibility, is that I put the wrong capacitors on it. This thing should be sensitive to 1028, and we've got it sweeping from 500 to 5,000, I believe. So we should be seeing a more significant change at lower frequencies. Let me change the sweep from the start frequency. The stop is 5,500. So there's a time thing on this. That doesn't matter. Start is going to be 100 hertz. So it'll start at a much lower frequency now. It's just not getting any... Yeah, it's just not getting any louder. This is with the minimum resistor value. Let me flip the potentiometer around, and now we have the maximum value. Well, that's staying pretty small there in the slightly higher frequencies. That's getting pretty small. A little counterintuitive. So it gets much dimmer there. Still think something isn't right. Now, it does seem to kind of favor the frequencies. Like if I put this down to 50 millivolts, oops, put this down to 50 millivolts or maybe 20. There, maybe if I modify that extremely, you can see how it's kind of getting, how the waveform's kind of starting to squish down as the frequency goes up. Look at that. Yeah, so I think it is working. I think it is working. Hey, Gonad, you missed an entire fun time of analog audio shenanigans. I don't know how much of this you've been here for, but I know you know a lot about this stuff. But we're working with the graphic equalizer right now, and I'm pulling it through what is it, 100 hertz to 500 kilohertz frequency sweep. The reason there's no light right now is because if I turn on my desk lights, we get incredible amounts of noise. First try. Yeah. So it is technically working. It's just working on a slightly smaller voltage scale. Should it flatten out after a certain frequency? Well, they exist as bell curves, so I don't think so. Not according to what Elliott Sound was talking about. That wonderful diagram that he has. Hold on, let me pull that up. The wonderful diagram from the Elliott Sound projects. It's all the way down here. That guy right there. So, technically, it should get much quieter at the higher frequencies. Look at the frequency response, figure 7. Yeah. Yeah, it's not going to amplify it. It'll only attenuate it. Well, I mean, yeah. So, but the problem is we're not really seeing we're seeing a much smaller gain on the output. So, but I think when we recombine it with the other filters, it'll probably regain a lot, I guess. I don't know. But I mean, the effect isn't as pronounced as I would like it to be. I thought it would be a little bit more pronounced. Maybe that has to do with the resistors that I'm using on like the 100Ks and stuff. Maybe that's what's affecting the response. Oops, turn that off. There we go. So yeah, the only thing that we're really seeing is we're seeing it at its peak somewhere around, and it doesn't really tell me what it's outputting when it peaks. I mean, we can almost see it here. It's like 2 point something kilohertz is where it peaks, right about, see it peaking right there. And then as the frequency moves up, it gets lower and lower in amplitude. Now, if we took the fast Fourier transfer of this, channel 2, FFT, turn that on, we'll see our frequency running through right there. You can see it starting and then sweeping through. We could probably cut off all of this in this thing, but you can see it running through the frequency right there. If we could plot that out, we could probably see whether or not it's attenuating properly. Hertz per div. Oops, 0 dB offset. Hertz per div. 200. Parameter limited. Ugh. Center frequency. $25, $24, $23, $22. I'm just gonna have to manually enter. Our center frequency, I can't manually enter it. Really? I gotta sit here with this knob. I want it to be like 2 kilohertz. I gotta sit here and do this. 13, 12, 11. If I click this, will it? No. 10, 9, 8, 7, 5, 4, 3, 2. Okay, so somewhere around there, we should be seeing a lot of activity, but the scope is having trouble taking a fast Fourier transform with this sort of granularity to it. Was that it going by right there? I think that was it going by. Look at that. There it goes. That's not very good. Let's turn up the hertz per div. That's the offset. I keep fucking with the offset. Stop touching the offset. 5 kilohertz per div, which means we should go 1 div, which is really useless. Come on. Man, the scope can be such a trouble. 2 kilohertz per div. There we go. There's our signal. It does not appear to be getting louder or softer according to the scope, though. This is from 100 hertz to 5500 kilohertz. Where's my signal? Bring that back. Hold on. Yeah, this thing's FFT function is a little bit convoluted. I just moved it up a little bit and it like froze. There we go. There's peak fuck you mountain. So that's 100 hertz to 5500 kilohertz. So 100 hertz to 5500 kilohertz. This is a fast Fourier transform. So this is all the frequencies that are evident here. If you build the middle EQ, it starts at 8.7 kilohertz. No, we didn't build the middle EQ. I have a different value on it. So according to Elliott Sound, you know, maybe we can test. We'll test it up to 8 just in case. But according to the tables that identify the different circuits, which maybe I got confused. That might be one thing that happened here. What I jotted down though was 1028. So I have a 0.022 microfarad capacitor in there. So that should be 1028. Double check. Which ones these are close to 0.022? I think it was like this one. That says 870 hertz. But that's still within range of what we're sweeping. Yeah. 0.022 UF. What's that in NF? 22. Ah, so it's way lower than anything that he has there. Ah, so I'm going to have to, yeah, 22. Oh, here we go. That's right. It works in the opposite direction. Yeah, so it is around 870 hertz. Somewhere around 870 hertz. Which makes, this thing, turn off. So yeah, right around here, maybe. Because that's what... Yeah, it'd be like around here. So yeah, that looks about right. 870 to 1000. It should be 1028 according to their stuff. And the center frequency in this case is 1.8. So yeah, just about when we get to the 1.8, we hit the peak, and then you can see it tapering off. So it is actually the amplitude, which is the distance between the waves here, is going up and then down, and you can see that happening. Okay, science! We actually did do it correctly. It was just a matter of visualizing it. Okay, so that's the effect of the graphic equalizer, which means that our end frequency would be a bunch of these filters put together. The dramatic effect of this thing is not as evident, though. Let me flip it to the opposite end of the adjustment. So now we're at full whatever the opposite is. Full nothing, full attenuation maybe? Looks like the 100 hertz is still there. Like quite a bit. And it's tapering off rapidly. But yeah, it's getting all the lower frequencies are getting through. Shouldn't it be limiting a lot of these? Interesting. I mean, maybe it's below the level of the hertz. What number are we on according to this thing? According to this thing, we're like between number 4 and number 5, right? We're somewhere around here. So I mean, the lower frequencies, like, well, that's 20 hertz. Can we get this thing to sweep from 20 hertz? I mean, we can't display it. No idea what's going on, but it's interesting. Thanks, man. So let's start frequency will be 20. And the end frequency is still 500. That's going to speed up our frequency deviation a lot. I guess it is getting a little larger. Audio filters are magic. Well, this one is way less pronounced than I would like it to be. I think we might have to go with panometric, if panometric is going to be more pronounced. Now, this one should be accentuating the lower frequencies a little bit more, but it should be building up and then going and then tapering off. Let me put the higher frequency capacitors on this thing. We can do that very easily with a perforated prototyping board. So I'm just going to rip these out. Hopefully you guys don't hear anything on your end. I'll put in the, I think, higher frequency ones. We'll see what that does to our sweep. I just pulled a resistor. That's not what I wanted. We do only have one filter, but, you know, we got to take baby steps. So one goes like that to ground, and then the other one goes, it goes over here. Jesus, there's a fucking spark. Oh yeah. Oh yeah, look at that. So from the higher frequencies to the lower frequencies, it seems to be, or sorry, from the lower to the higher, it seems to be building up. So yeah, the combination of these filters are what's key. Let's go up to 10K. Start. 20 hertz. Stop. 10. 0, 0, 0 hertz. Get a little louder and louder and louder. Louder and louder and louder. Okay. I'm liking this now. I'm liking this now. And then if I use the opposite end, it will stay at lower volumes the whole way and still have a bit of a bell curve. Slightly lower. It's not amazing. Maybe I could use more than a 10K potentiometer, but I already ordered a bunch of these things. I kind of want to use them. Yeah, and according to the bell curve, it like, technically it probably should be tapering off, but like, if you have one that goes to the lower frequencies, it's going to taper off more at the higher frequencies. You go on at the higher frequencies, it's going to taper more off at the lower frequencies, unless we go over 20K. So let's try going over 20K. Let's go to 20K. So at the stop frequency, 20,000 hertz. Luckily, this thing can still handle it, but yeah, builds up, and see that? It tapers off a little bit. Oh, that's perfect. Okay. Oh, look at that. And we get more of a representation of it on our fast Fourier transform. Fourier. I don't know what to call it. Man, everybody clicked off of my friggin' page. Everybody's tired. All the Scandinavians went to bed. Yeah, it's 5:30. We're at stopping time. Closing time. We're at stopping time, and we have results. So I was able to finally get this thing all tuned up and working, and you can see a little bit of what is happening. You're still here? Oh, god damn it. That was your first message ever. Yeah, so no, I'm happy to have you guys here. You guys are great for sticking with me through this. There's a little bit of a face and ball scratching that goes on, and hopefully use different hands for each one if you're doing them simultaneously. But we were able to get, first of all, on what was it, Saturday? Oh, I don't have a white noise generator. I think that other piece of test equipment that a user sent in does white noise, but I don't have it. White noise would be good for the fast Fourier transfer, because under FFT, I could try to tune out white noise to look like this, or to look like my mic filter. But for now, we know that we can tune these guys, we can tune the individual filter blocks to specific frequencies. I need to find capacitors that are going to allow me to get close to my audio setup with those. I need to hook them up and test them within the body. Thank you for following. Yeah, so we'll need to figure this out a little bit more, but what we've got here is on the scope, we have a frequency sweep coming from this cheap piece of electronics kit that I put together. A little frequency analyzer. It's a fun little thing to build. It's helping us out with this. It doesn't do white noise, but it does do a frequency sweep. And so we're going from 100 hertz to 10 kilohertz, which is, I don't know. Are we going from 100 or are we going from 10? I don't know where the start is. It doesn't let me check. All right. I think we're going from 10. I'm going from 10. 10 hertz to 10 kilohertz, right? And as we sweep across, we can view the amplitude of the different frequencies with a Fourier transfer. And that tells us what frequencies are present on the line. And if we plot that carefully, we can sort of see it ramp up, and then we would see it ramp back down over here. If I could move this over. I don't know how to do that. I think if I move the center frequency up a little bit, That's the wrong adjustment. Wrong way. 7 kilohertz. Where's that put us? Trying to move this over this way. The problem is it's logarithmic, so 20 kilohertz as the center frequency. See what it does there. Nope, that's too far. Well, we can see its sweep. Oh, nope, and then it goes away over there. Yeah, 20 kilohertz is way too high. Shit. All right, 0 volts. Sorry, hold on. And then try that, 13 kilohertz. I think this is on a logarithmic scale. It takes it a second. Oh, that's a pretty good display. I need to go down a little bit more. Okay. So if you watch this thing at a 0 dB offset, you can see the frequency coming in on one side, and as it sweeps across, it gets louder and louder, and then it starts to fade out as it gets into the higher frequencies, and that's exactly what we want. Why does it ramp up at the center frequency? Because that's exactly what it's supposed to do. That's the circuit that we've built. So the function of this is to allow for adjustment of the audio, because right now I have it set to not lower the volume of the frequencies. When I do have it set to lower the volume of the frequencies, the summation of all of these bell curves will become this, hopefully. Pyro did a little bit of work actually trying to make that in LabVIEW, and was able to actually do that. So the question is this going to give me is this filtration method going to give me my beautiful sound, or are we going to have to do the op-amp whisper down the lane method? So that's what I want to evaluate with this project. That's what we're working towards. When we get to a good design, that means we can jump into the world of three-dimensional circuit design, of which I've modeled already the microphone pack, and I could try to fit all of my electronics into that. What that means is that I will have an equalizer attached to this microphone specifically for this physical microphone that I'll be able to plug into a mixer and get an appropriate amount of sound out of. And then that will be amplified or you know, whatever, according to the compressor. I mean, it would be fun to pull it into an FPGA, and then I could put both the compressor and the EQ on the same thing, but I would need to figure out how to make an interface in order to program that. So it doesn't need to be exactly my frequency response. It's just as long as you get it close enough, it's a proof of concept of this methodology. The problem is, I mean, the amount of emphasis, the amount of emphasis and de-emphasis I see at the different frequencies is not as evident as I would like it to be. I mean, it looks pretty crazy from here, so maybe it's okay, but it is significantly lowering the gain on the output. So we might have troubles with that. But then again, when I mix it with all the other frequencies, maybe we get back a lot of that gain. I'm not sure. So I'll have to play with it, and maybe I'll also start building up the op-amp circuit. But anyway, that was as much of a success. That's as much of a success as I think we can get around here, you know? So I've managed to, first of all, one of the early accomplishments, first of all, I've been able to fully replicate my microphone amplification circuit and plug into it so that you guys were listening to me talking to you through the perforated prototyping board. Solderless breadboard. God damn it. Anyway, I was able to talk to you guys through the solderless breadboard, and it sounded exactly like the microphone that I'm talking to you right now. The other thing that I have, this is a fully surface mount circuit inside of this thing that contains exactly the same, well, similar components. Christmas is coming. Want to make another pedal? I don't know, man. I have to dig up all his files. Yeah, Elliot expects plus to minus 15 volts, but then again, these are just regular 3904s, so I think it's all working within parameters. Because there's no way for me to give it more than 10 volts. And in his other circuits, he's powering the same op amps with 10 volts and getting the same results. So I don't know. I mean, the op amp is still comparing between the same stuff, right? It's still comparing apples to apples. If I go to op amps with this, maybe then it could be apples to apples. Okay. Yeah, I might be able to do that. Probably will be able to do that. I don't know. The next couple months. Okay. That's like stage 0.001 of this project. We got a lot of places to go with this. Deciding on the circuit is the fun part, because that means we get to plug into all kinds of weird stuff and, make all kinds of weird circuits. Keep in mind, we're actually hitting this with a lot more volume, too. This is being hit with a 100 millivolt. Actually, no, we voltage divided it. So actually, no, we are hitting it with the appropriate circuit, yeah. Output power supply is a range. Only thing that matters is the maximum. That's what I mean. Is that plus or minus 15? But if my whole circuit is plus or minus 10, or 7.5 volts to whatever, then all of that stuff is shifted around, but it's all in comparison to itself. So all the inputs and outputs, as long as the gains are similar, it should be similar. I may need to adjust for the difference in gain between what this is doing in terms of gain and what this is doing in terms of gain. So yeah, that may be something that needs to be adjusted, but the effect is still there. We still see the effect of a sort of a subtle sweep. And maybe if I adjust the inputs or the outputs, it'll be a little bit more prominent. Okay, that's all I got for you guys today. Let's see. Anything going on? Davies is probably still doing my summer car. What's Tamta doing? Some kind of a weird game. Age of Empires. League of Legends. Ugh. More of Inscription. Everybody's playing card games, aren't they? Painting with Borb is on. Minecraft. And then Adam is editing. All right, I'm going to leave you guys to your own devices. I'll just say that. I'll just leave you guys to go. Yeah, we don't have lights on because of the... Here, hold on. Set up lights, desk. There we go. That's my side light. That gives my face a little bit more definition. Could the phantom power give you 30 volts for plus minus 15? I don't want to do that, no. It could probably give me plus or minus 30 volts, but I don't kind of want that sitting there. Happy birthday. Thank you. I appreciate that. Yeah, I'll be on in a day and 19 hours and 5 minutes and give or take 44 seconds. It's probably one day, 20 hours and 5 minutes and 44 seconds, but you know how it is. On Thursday, we're going to work more on Burn the Subs, and it's going to be more Fusion 360. Only this time, I'm not going to concentrate on building that circuit board. I need to put holes in the circuit board. I'll probably work on that tomorrow, and depending on how motivated I am, figure out whether or not I want to add all the connectors and stuff to it. And then we'll have a stream on Thursday where we can actually place things in space, and we can build a 3D printed solid around it. I can then print it, put it on that thing, put that thing on the board. Then our hardware is almost 100% ready to go once I install all the limit switches with all their little 3D prints on them and everything. And then we'll have Burn the Subs 2.5 hardware zone ready to go. Then we need to jump into programming. We need to make a Python program that's going to use a controller so that we can map the edges of the board without scorching the whole fucking thing, right? All right, until then, I bid you adieu. I will be on Discord. I'll tweet any weird stuff that I figure out. And, I'm working on this. I'm working on Burn the Subs. I'll see you guys later.